hurt my feelings, but it's in the room right across the. You actually, that will hurt my feelings. but if you have to go, I would go ahead and go. No, I think one of the programs had the OpenSAM talk also in Lab 003. So if that's the talk that you intended to go to, again, it's right across the way. Since everybody's still here and nobody hurt my feelings, well, good. So today we want to talk about hybrid analysis mapping, which is some research that we did at Denham Group, some research we did in conjunction with the U.S. Department of Homeland Security, and we'll talk about some of the benefits that came out of that research that we actually didn't expect when we set out on it. But we've put together what I think are some interesting ways to make development tools do security better, and for security tools to be made better using some benefit from the development tools. Here we go. That's a picture of me, in case you were unsure of what I look like. I'm not entirely sure why that gets included every time, but that's fine. I'm Dan Cornell. I'm the CTO and founder of Denham Group, and my background is as a developer. Started out initially doing a lot of early server-side Java stuff. In the early 2000s, I did some early ASP.NET stuff. But what I've really spent the last 8 or 9 years of my career doing is looking at how developers and how folks developing software impact the security of their organizations. And so asking how does development impact the security posture of an organization, and how do you get developers to build more secure software on a more repeatable basis? And so that colors a lot of what I talk about, or how I describe this, I think. But again, I come at this from a development background, coming into security. Again, been involved in OWASP for a long time. I help run the OWASP San Antonio chapter, and so on and so forth. And so what I want to start out talking about is looking at what security teams typically want, what their goals are, and to contrast that with what development teams want, and to look at the types of tools that each of those organizations tend to use. And that'll set the stage then to look, we'll talk through this research that we did on what we call hybrid analysis mapping, which is looking at how, the initial research was looking to see if we have results from a static analysis tool, code review tool, and if we have results from a dynamic tool, a web scanning tool, can we merge those together? Essentially a data management problem. Is there a way that I can take these two different data sources and stitch them together so that people don't have to do that manually? And then we'll look at, I'll talk through some of the internals of what we built and the outgrowth of that. Some additional tools that we were able to build based on that technology that are all available for free, open source, downloaded from GitHub. And we'll have links and pointers to all that stuff. And I'll go through some demonstrations of the tools that we built and how those can help solve certain problems that we see development teams facing, as well as security teams facing. And we'll have, I think, some time for questions at the end, but this is a good-sized group. If you have questions along the way, please feel free just raise your hand or wave your hand at me and stop me, and I'll address those. Any questions so far? All right. Everybody's still committed to this talk and not going to the OpenSAM talk? That's good. We're even getting new folks. This is great. All right. And so, again, just career-wise, I've had the opportunity to work both on the development side as well as on the security side, and that's given me the ability to see kind of how these different teams work. And development and security teams certainly have different goals. They get rewarded, they get compensated and rewarded in different ways, and that leads to different behaviors. And they also use very different tool sets, and that's one of the big challenges that I've seen as security organizations try to go and work with development teams. This is starting to change, but a lot of the more traditional security folks, the security practitioners, don't have a strong background in development. Again, at OWASP here, I think we see a lot of really good and healthy crossover, and we're seeing more of that in the industry. But if you look at the installed base, if you will, of developers and the security teams that are trying to work with them, there's not a tremendous amount of crossover. In fact, it's interesting talking at like ISSA events. You'll ask, hey, how many of you folks, have a programming background? And lots of people raise their hand, and you say, well, how many of you have a programming background that's not in Fortran or COBOL, right? And all the hands go down, right? And so so that's a challenge because you don't see a lot of, again, more traditional security folks that have a strong background in modern web development, where they understand, Java, they understand .NET, they're used to building, modern web applications. The challenge is, and this is one of the reasons why I think application or software security is so hard, but also why I think it's a really interesting area in which to work, is like these groups have to work together. The development team, if left to their own devices, is probably not going to create fast code unless that's a critical business thing. They get rewarded for writing code that has a suitably low number of bugs and getting it done on time, and by whatever means necessary. And if you look at how developers manage their workload, typically most development teams are using some sort of change management tool, often a bug tracking, defect tracking system, right? A lot of folks using Jira, Bugzilla, bigger organizations, HP Quality Center, stuff like that. That is where the to-do list for a lot of development teams live. That's how they get work. That's how they manage their workload. And if you look at where they spend the majority of their day, it's in their IDE, it's in their integrated development environment. That's their window to the world. That's where work gets done. And so there's challenges when you see security teams come around and say, for security purposes, right, you're doing all your work over here in your defect tracking system. That's how you're tracking all your work. But instead, for security, which is a magical, separate, special thing, you need to do your work off of this 300-page PDF that I've printed out and put sticky notes on the stuff that I think is important, right, from the scanner, right? Or you need to log into this other system to manage your security workload as opposed to using your defect tracking system. And so that creates friction, right? And in a lot of cases gives developers an excuse to say, I was going to fix security bugs, but it's too hard, right? Or it was easier for me to work on this other stuff as opposed to fixing these security bugs. If you look at security groups, it's what's our policy, right? What are our standards that we use to try to meet that policy? How are we managing risk? And the goal is to keep the world safe, right? Which is a much more amorphous goal than most development teams have. And what we've seen is a lot of network and infrastructure tools and paradigms are kind of getting crammed down on the development teams, right? And so folks say, well, for network security, we use network scanners, right? And that solved the network security problem. So why, if we've got a network scanner to find problems in networks, why don't we make an application scanner that's going to do the same thing for an application? Or, right? Or we used firewalls to solve the problem of hackers and keep them on the outside. In the network and infrastructure world, let's make an application firewall that's going to perform a comparable function over here. And so I think we've seen a lot of the dubiously successful paradigms from network and infrastructure security applied in an even more dubious and less successful way in the application in the application space. The problems with security tools, if you're a security person, again, if you're coming into or if you're coming into software security from a background as a sysadmin or network or infrastructure person, if you don't have a strong software development background, it can be really challenging to use static analysis tools, right? And certainly it would be challenging to use them, and it's even more challenging to use the results that come out of those static analysis tools. Right? It's really tough to get a clean or a good static analysis run if you don't know how to run a software build. If you've never used Make or Ant or Maven and don't understand that process of how software dependencies get to put together and libraries get to put together, it's going to be really challenging for that person to be successful running a static analysis tool and dealing with the results. Right? And that's another challenge in a lot of cases with static analysis tools is the plethora of results that you see coming out of them that you've got to be able to look and say, okay, well, this is the important stuff, this is the stuff that I want to check next, and this is the stuff I'm going to get to when I have time. Again, in the absence of a strong understanding of how applications are constructed, how applications get built, and how the code works as traffic flows through it, it's really challenging to be able to interpret those results successfully. Dynamic scanning tools have their own challenges as well. They've got to be properly configured to get good coverage. And I tell this story all the time. We were working with a big financial organization, and they said, "Hey, we ran this fancy commercial scanner on our application, big 500-page Java-based web application, and we found no vulnerabilities. Right? Security is solved in our organization because we got a clean scan." Took a look at the scan results and said, "Well, you scanned the home page and the login page." you didn't train it to log in, so it didn't actually check the other 498 pages in the application. And I suspect if we take a closer look at those, then there might be a couple problems that you need to be concerned with. So don't break your arm patting yourself on the back just yet. We've still got more work to do. And that's a challenge with the scanners. Even if you've got them successfully configured to log in, scanners need to understand the application. They need to be able to properly spider the application to understand what the attack surface is, so that they can fuzz and exercise that attack surface to get good results back. The problems that we see with security tools, if you're a developer, is, again, I mentioned this before, developers don't speak PDF, right? If you go, and we see this pattern over and over again, security comes in, runs a scan, generates a 300-page PDF with the color graph on the front page, hands it to the development team and says, I did my job, it's your, fix it, right? Apparently you guys are bad at software because, we got a 300-page report and the graph's in color. And there's a lot of red on the graph, which, and so you guys need to go for it. Even worse, what we see is organizations where they run two different scanners, right? Hey, we went in and ran this scanner, we ran this scanner. Now we have two 300-page PDF reports with two color graphs on the front page, right? 600 total pages of results, and it's, well, hey, some of these are probably repeated, but we're not sure which ones, right? And the challenge there is that gives the development team every excuse in the world to push back and say, like, you are actively wasting my time, right? I'm going to go to my VP, who we've made promises to for important customers. I'm going to go to my VP, and guess what? Security is no longer going to be a priority for this organization. And so that's a really big challenge. So developers don't speak PDF. For the security teams that have been nice enough to correlate all this stuff manually in an Excel spreadsheet, I'm sorry to let you know that despite, they're probably selling a Rosetta Stone for it, but developers still don't speak Excel either, right? And so trying to communicate with developers, we found that to be universally ineffective. And in a lot of cases, taking action for developers on dynamic scan results can be challenging, right? If you say, well, hey, you've got a cross-site scripting vulnerability on, if this URL for this parameter, in some environments, in like a kind of basic PHP or classic ASP environment, okay, well, the name of the URL matches pretty well with the name of the file, right? And so that may be relatively easy to track down unless you've got different things that are included or something like that. Right? But in modern web development frameworks, your login.jsp page might not be in login.jsp. It might be in com.whatever.login controller if you're using something like Spring. And so in a lot of cases, it can be challenging for developers to take action based on these dynamic scan results. And again, looking across, so taking a step back and looking at this, the developers have a lot of stuff to get done. They've got security fixes that you want them to get done, and features and other things that other people ask them to get done. From a security person, if you want to see them take action, you have to take excuses off of their plate. You have to reduce the friction in the process. And in doing so, what we've found in environments is that you start to get better activity from the developers. If you're working with them in the tools they're working in, if you're speaking their language, you're taking friction out of the process, and you're going to see developers start to make a lot more progress in on security tasks. So how do we make this better? Well, developers certainly need to know more about security. They need to learn more about security. You're not going to make every developer into an expert, but every developer should have some background, authentication, authorization. Why do I do input validation? How do I do contextual encoding? What are the libraries we use to conquer these different tasks? And so, that's certainly the case. But again, it's unrealistic, I think, for security teams to expect every developer to be an expert in things like this. Similarly, security teams need to learn more about development, right? This, like generating a scan, saying, well, I used to use Nessus to run scans against the network, and that gave me this that a PDF that I took around, saying now I'm running an XYZ scanner, that gives me a PDF. That's not going to be, again, that's a message that's not received well by developers. And so security teams need to learn more about how development teams work. Because, again, what you want to be able to do is go and speak to the developers in their language, and that's going to get you better compliance. You're going to be more effective in getting developers to take action if you can, if you can speak to them in their language and work with them in the tools that they're using. So what? The genesis of this presentation was some research that we did with the U.S. Department of Homeland Security. And we basically, they had asked for solicitation. They said, here's areas that we want people to do research in, make a proposal, and we'll respond and possibly give you some funding. And what we were looking to do is to better integrate not security and development tools, but to make security tools work better together. And most specifically, we wanted to make dynamic scanning tools and static scanning tools work better together. We saw a lot of organizations where they were doing static analysis, they were doing dynamic analysis, in a lot of cases with tools from different vendors. And the result was we've got this PDF and this PDF, and if I want the data to work together, I have to take all these results from static and all these results from dynamic and dump them into an Excel spreadsheet and spend like way too much time trying to stitch this stuff together. And so, what we originally set out, like our phase 1 goal of this research, was to determine if it was feasible to take the results of a Fortify scan and an AppScan dynamic scan, and stitch them together. And so, from a dynamic security testing standpoint, how do most of the dynamic scanners work? They, first have to figure out, like, what is the attack surface of this application that I'm going to be looking at, so that I can then move on to the next step, which is to fuzz that and look at the request and response patterns to determine if it looks like if I send this request and I get this response, that's indicative of a cross-site scripting vulnerability, or that's indicative of a SQL injection vulnerability. Everybody here's familiar with dynamic scanning tools, hopefully. Everybody? Similar in the static scanning tools, they look at application source code or an application binary, build some sort of data structure that represents how the application, how the application is structured, how it's supposed to work, and much like a compiler or virtual machine would, and then they perform some sort of different types of analysis in order to determine what if there are patterns that would be indicative of certain vulnerabilities or weaknesses. And so here we can see. Right, we get parameter, returns dirty or tainted data. That goes in username. That username gets appended into this string SQL, which is then also tainted. That gets fed to execute. And so that by being able to draw a line between this tainted input and this sensitive sync function, the static analysis tool is able to say, like, oh, okay, well, this is indicative. This pattern is indicative of a SQL injection vulnerability. And so these are different types of analysis. One of them is looking at the software in at rest, and applying pattern matching to the structure of the software to try and determine if there are issues. The other is exercising a running application with no knowledge or little or no knowledge of how that application is structured. So it's a black box. I send this in, I get this out. So our goals for this research were to figure out, can we standardize vulnerability types across these two different types of tools? Can we find a way to match the location, right, of if I have a certain request and response pattern, can I determine in the software where that request hits and where that response comes from? And can we figure out more about what the specific entry point to the software that is causing the problem? Can we identify those particular entry points? And so, drilling into this, we basically needed to create some data structures in order to do this, and create a model, and then run some tests to determine if this were possible. We built this on top of an application that an open source application that we put together called ThreadFix. And what ThreadFix is, it's an open source platform for application vulnerability management that lets you basically load in the results of different static and dynamic testing, both automated and manual, normalize and deduplicate the results, and then manage those through the resolution process. And I'll show some quick demos of that. But this was a good base for what we were looking at doing, because we could already do dynamic to dynamic matching, right? You could load in the results of a W3F and a ZAP and an AppScan, and and ThreadFix will take those in, normalize the data, and give you one single view into those vulnerabilities. Similarly, we could do it on the static side, where you could load in the results of like a Fortify, an ounce or whatever. Again, it would normalize and then dedupe that data. And so it made sense to include this technology on top of that, so that we could take the static results and the dynamic results and stitch those together as well. That's a picture. That's a list of the different tools we can talk to. That's a slightly more fun page with pictures on it that basically says the same thing. And so in doing this research, we had to figure out, like, what do we consider to be a unique vulnerability? And in the dynamic, for dynamic results, basically we decided on the MITRE's CWE, their common weakness enumeration, as as our taxonomy for vulnerability types. And for dynamic results, what we found was, for certain types of vulnerabilities, just matching the CWE and the relative URL, it was sufficient to indicate a unique vulnerability. And so, if you have predictable resource location, if you have like login.php.back on the server, that's indicating probably some bad configuration management. It's easy to guess that this thing is here. It's probably not supposed to be here. And if two different scanners find that CWE with that same URL, again, probably the same issue. Same thing with like directory listings for misconfiguration, other stuff like that. If you're looking at injection flaws, things including like SQL injection, cross-site scripting, all of those injection flaws, then a unique vulnerability, according to our data structure, is that CWE. What type of vulnerability is it? What's the relative URL? But also, what's the injection point? And so, what's the name of the parameter that gets passed in that is being mishandled? Or what is the name of the the cookie or the header that you're sending in? Again, so by taking the results of these different scanners and normalizing to that, we're able to take different scan results on the dynamic side, load them in, and and end up with a consolidated list of those vulnerabilities. We picked the MITRE CWE. There's like every vendor has their own taxonomy that they use for keeping for describing how vulnerabilities are. We originally tried to create our own, which was probably misguided, and ended up working with settling on the CWE. It's funny when talking to the MITRE guys, or I like to say that the CWE is the worst vulnerability taxonomy out there, except for all the other ones. Right? It's like the democracy of vulnerability taxonomies. So CWE is exhaustive. It's a little sprawling at times, but it's a reasonably well-adopted standard. A lot of tools already had the mappings that we needed there. And so again, we found it to be a pretty workable solution, and certainly one that is better. It makes life a lot easier to use something like the CWE versus trying to maintain something like our own thing that we made up. It also helps us integrate with the again, as we communicate this data, or if we need to normalize across different organizations, it makes it easier to do that. So with our research, what we did is we passed in to the technology, the engine we built, some amount of source code, either via being able to pull it from Git or from a local file path. Git usually works better because ThreadFix is a server-based application, so it needs to be able to get to the software. So like a relative file path from the server is a hard thing to set up via a browser. That's kind of a weird concept to set up. It's easier just to say, like, here's our Git repository, this is the branch that we're on, and here's the username and password, so they can get access to that. We also pass in or automatically detect the framework type. Right now, the technologies we support for this hybrid analysis mapping and the associated tools are Java-based. Java, JSP, and Java Spring applications are supported. We're working right now on ASP.NET MVC, and we'll have Visual Studio and associated plugins coming out soon. And then, in this case, because we were looking specifically at matching Fortify and AppScan results, we went to see if we could pull some additional information from Fortify as well. So for the vulnerability types, again, we basically standardize everything back to the CWE. And we did some looking at software fault patterns. I don't know, for folks that are familiar with the MITRE CWE, they've got some associated vulnerabilities. We tried looking at matching across those. That wasn't really effective. But again, so what we do is we map everything back to the CWE, and we create a unified endpoint database. And so we do this lightweight static analysis of the application, where we run over the source code, detect the framework type, and we build a database where we basically calculate the attack surface of the application. And so we look across the code and take evidence from the code where we say this URL, like this application is going to expose the URL login.jsp. And the reason I know that this application is going to expose login.jsp and a username parameter is because I found a get parameter call in the file login.jsp, or because I found a call to, in a Spring situation, I found a reference to a model element in com.xyz.login controller, right? And so we build this database where we say, I think I'm going to have this piece of attack surface in the application, and that's based on this line of source code. So we go through the code, build this database, and then then we're in a situation where we can query that database and say, hey, I've got something here on the attack surface. Tell me what source code is responsible for that. Or you can go the other way and say, for this piece of source code, where can I expect this code to be attached to the dynamic running application? And in doing that, that let us do the static to dynamic matching, because we could basically say, well, I've got my dynamic scan results, again, that says I have a SQL injection vulnerability at login.jsp for the username parameter, right? On the static side, we could say I've got a SQL injection vulnerability, and the source function is at com.xyz.logincontroller line 93. All right, when we run those against one another, we say, okay, well, I've got this SQL injection on the dynamic side on the attack surface matches up with the SQL injection in the code at this location. You know, these are probably representations of the same vulnerability, so this request goes into the code here and comes out there. And so we can do that and match and consolidate. So that let us, we were successful in doing what we wanted to do, which was to figure out, like, can we massage, or can we manage this data such that we can link up static and dynamic results. The cool thing that came out of that, so we're sitting in a meeting and we're talking about how this is laid out and figuring out, like, okay, we're getting X percentage of matching. And then the question was, well, wait a minute. If we just queried this database, right, and said essentially like a select star from this endpoint database that we had, won't that tell us the entire attack surface of the application, right, independent of whether or not there's a vulnerability at those, at those points on the attack surface? So even before we've done the dynamic analysis, since we have this model, can we build, an attack surface model of the application? The answer was, sure, we can just write another function to pull that data out. And similarly, we asked, well, even if we haven't done the static analysis, if we have these dynamic results, can we determine what the line of source code that the developer needs to look at is? And the answer was yes. And so, coming out of that, what we figured is we can do some interesting things beyond what we originally looked to do. Just to talk a little bit about the technology under the hood, basically to parse the attack surface locations, in a JSP environment, we start with the root JSP folder, and figure out the different files and files that get included. It's fairly straightforward. You've got to watch for some infinite recursion stuff and whatnot, but basically, those are just files laid out. The structure of, the structure of the site from a dynamic URLs that are exposed from that standpoint matches pretty similarly to what the directory and file structure looks like. In a Spring environment, this is more complicated, but basically what we do is we go through and we parse all the @controller classes to determine all of the attack surface, all the URLs that get exposed and whether they're get or post, or whether they listen to gets or posts. And then we parse the model classes to determine what parameters can be passed in. Similarly, in a JSP environment, we look for calls to get parameter right now, and we do some lightweight data flow analysis to see what gets passed in there. And in Spring, we parse the request params, path variables, and entity annotations. And so in doing this, we get this bridge that we use again to do this static to dynamic mapping. And so the question that we asked from this was, if I know the attack surface of an application, can I feed that back to a scanner to kickstart the spidering process, right? And this goes back to the story about, like, hey, I ran a scan, and in my 500-page application, we scanned 2 pages, right? And so it's a question of, can I, if I know about the application's attack surface, can I seed the scanner with that information so that we get more thorough scanning? And the answer is, as long as the scanner has the ability to customize in that way, yes, you can, right? And so in calculating this attack surface model, we can feed that data to a scanner so that it knows what, it knows all the URLs it should be able to get to. And so that spidering process that the scanner goes through, where it says, okay, I'm going to start with the home page. Let me find all the links on the home page, right? I'm going to go to each of those pages and look for the links or forms that go off of there. Again, the scanner is probably still going to want to do that process, but you can seed it and essentially say, based on our model, here's every URL that this application should respond to, and every parameter that you should be able to feed to this application and get some sort of behavior change from the application. And so using this data, again, we can make the scanners smarter so that they can, so that you can get better scan results, or your starting point is not trying to guess what parts of the application are there. You already know, or the scanner already knows what application stuff should be responding, and so you can get a more thorough scan. Similarly, if we go the other way, even if you haven't done a full-blown security static analysis, if I've got dynamic analysis results and a model that takes the, that takes each attack surface location and maps it to code, if I know that I have a SQL injection at a certain attack surface location, I can get the line of code responsible, not necessarily for the entire vulnerability, but I can get the entry point. And so what we figured is we can also go and make plugins for IDEs that take the results of a dynamic scan and map that back to the line of code. So in the static analysis world, all the static analysis tools have, have IDE plugins. At least most of them do, which is great, right? Because that's helpful for developers to say, right, I'm going to tell you that there's a problem, and I'm going to show you exactly where that's at, right? Which is a nice thing to do for developers if you want them to take action. In the dynamic analysis world, I don't know of anybody else that's doing that right now, where they can say, here's a dynamic scan result, and by the way, developer, here is where you need to go to start, to start trying to solve this problem. So based on this, we saw opportunities both to make the security scanning tools more thorough, as well as to put better information in the hands of developers so that they can do remediation more quickly. The basic system setup, we've got the ThreadFix server that has access to the application source code. We've got I'll show an example of working with the ZAP scanner. And so you can ThreadFix basically pulls the source code, builds the model, feeds it to the ZAP scanner that it then uses to inform its scanning of the target application. Those results get fed back into ThreadFix, and that data then with the lines of code and the vulnerability data, we can then send to an Eclipse IDE. Any questions about this? I want to launch into some demos, but I want to see if anybody had any questions about what we've done, or what we've talked about so far. Anybody? All right. Excellent.
Do any scanners have support for people to scan attack surface?
Right now, we've got plugins written for Zap and Burp, and we're looking at adding support to AppScan next. And with the data that we have, like a lot of scanners will let you feed them like a file, like a flat file. And so we've got a command line client that'll show you that you could probably run the command line client, fouiller around with the results a little bit and get a file that you could upload to something. And so
every scanner basically needs other type of data. It's not a common format.
Yeah, it's not a common format, but that's something we've seen some interest in, and I had a chance to talk to, I don't know if Simon's in here, Simon from Zap, talked to Farah from Mabatuna. I've talked to a couple of the scanner vendors, and I think that there's interest in having a standard data format for this. I talked to the folks at MITRE. I was talking to some folks at MITRE and some of their government clients a couple weeks ago, and I think there's some strong interest there in that. The OWASP DEF project, or Data Exchange Format project, that Tom Stage has kind of picked up the ball and is working on lately. So I think there's some interest in that. There's not yet a standard, but the nice thing is if someone wants a standard, we have, basically this data gets fed, in our environment. These ThreadFix just has a REST API that the scanner calls into and says, feed me the endpoints, and it feeds the endpoints via like a JSON response. And so if somebody wants a standard format, I have a reference implementation of something that works. That obviously if they're, as we build out the model and make it more elaborate, I think that's going to need to change. But we've at least got something that we've demonstrated work for this type of a use case. That we're happy to change it to something else if somebody has a better idea, or in the absence of a better idea, we've got a thing that works right now. Yeah. A very lightweight static source code analysis. And so it's not, and I'll show you, we've got a command line client, and I'll show you how quickly the command line client runs. That'll hopefully give you an idea of just how deep the analysis is. But we can also, some of the static analysis tools package, in their results package chunks of source code. We can also take that source code and build a partial model based on that. The matching works a lot better if you have access to the full source code.
Because in my company, our developers, they use Jira. They use checkstone, check the code, if the code is nicely written. They use Fineberg, they use CMD. And then they use one tool, Sonar, Sonar Cube, to aggregate all those reports. Now, they complain, of course, it's too slow.
Right. This, even compared to a FindBugs, this runs much more quickly than that. It basically runs through, because FindBugs and PMD or one case, and if you look at even a more significant case where you have a full-blown data flow analysis from a commercial static analysis tool, it takes even longer. This static analysis basically just runs through the file, tokenizes it, and looks for very specific chunks of text. And so it has the advantage of it runs very quickly, and you don't need to do a lot of configuration. You just point it there and it figures out and does the best it can. The disadvantage is you're not going to get the type of deeper insight that you would get from a commercial static analysis tool or even like a find bugs or something like that. And so, you know, again, like we run over a couple 10,000 lines of code in a second or two. I mean, the runtime has been negligible in anything we've fed to it so far for the depth of static analysis that we're doing, which again is pretty surface level.
Easy to extend to GSF, for example?
Yeah, and so let's run through real quick just to give you an idea. So the support that we have, the platform support for JSP is about 698 lines of code, of Java code. And the you know, about just under 1,500 for Spring. And so it's not something that you could, you know, it takes some time to go in and write the parser for the framework to get this, but it's not, you know, it's not ridiculous. And so we're right now working on ASP.NET MVC, and we've got a little bit of work done toward Python Django. But it's certainly something, and we've talked to, you know, I've talked to a couple people about the JSR 168, the portlet things, and stuff like that. So I think there's some interest, and if folks are interested in extending this stuff, you know, we're happy to support them in doing that. Basically, you have to implement this endpoint generator interface that emits these those matching pair of here's an endpoint and here's the source code responsible for it. And so it's been designed in such a way that, you know, if your organization has like a custom framework that we see in a lot of places, you know, again, it's a little bit of a development project to add in support, but as long as there's an algorithmic way that you can take source code and say this source code is going to look like this when it hits the server, it's something that can be extended. Okay, so just to run through, here. Basically, so this is threadfix. You can log in. See this here. And what we see here is, look at the different cross-site scripting vulnerabilities. And so here we see cross-site scripting vulnerability that was identified both by AppScan and by Fortify, where to the dynamic scanner, it was in the relative path /budget /contact.jsp. In the source code, it was in root/contact.jsp. We normalized that URL path, match the parameters, and then we can say, you know, these two scanners found this, and we're able to roll this result up into one. Another interesting thing that we see, because we have a model of the application that we've built, we can further clean up some of the data that we see from these different scanners. And so here's an example. What you see in a lot of cases with dynamic scanners is they don't have an understanding of how the source code is structured. And so what you see with applications that may have like a RESTful style of URL creation, you know, we'll have a vulnerability that's, you know, pet clinic owners /5/edit, owners /6, owners /7. Right? If a human looks at that, you say, well, that's not three different vulnerabilities, like this is all mapping to the same code. The scanners don't know that, but because of the way that we build that attack surface model, the hybrid analysis mapping knows we've got /owners, the next part is an ID, and then /edit is the thing that comes after that. And we know, like the model knows that all that maps back to the same line of code. Right? And so we're able to take these three vulnerabilities that were identified by AppScan and basically make a pass over those and consolidate it. And so that's another way that this type of knowledge, like, you know, if you take this knowledge of the application structure and pass the data from these scanners through it, what you end up with is a cleaned up data set, so that instead of developers saying like, hey, you've got three problems that you need to go fix here, you can instead tell the developers you've got one problem that you need to go fix here, and you need to go fix it at the code that is responsible for that piece of the attack surface. And again, from this, and we've got a, this is just a simple, we basically took the tech, you know, that's totally impossible for anybody to read, I suspect. And that's not any better. Okay, so that was basically we just ran and built the attack surface model for the Java Pet Clinic, which is a pretty small application. But again, if you look at the speed that went through, it's not, that's not process bound. But see, what we see here is that we've been able to figure out that like this URL / owners ID pets ID edit, you can either post or put to that URL. Oh, that's weird. Oops. And below it are all the parameters that can be passed in based on the model. Also looking at this, when I look at this, when I look at a Spring application, we're parsing the model and looking at the auto binding configuration. And so I also look at this and say, this auto binding is configured to allow pretty deep binding, which is not necessarily a best practice. And so as a manual pen tester or as a manual code reviewer, seeing that this is how, this is the parts, or this is the type of auto binding to be done, makes me think that, that there may be additional problems with that. But basically, this is just a command line tool that generates that attack surface model. And again, from a processing power requirement standpoint, that ran pretty quickly. Or we can go. All right. Oops. What did I do here? Hello. Huh. This is very bizarre. Of all the problems I've ever had with demos, losing control of the mouse is not something that I've ever had trouble. There we go. All right. And so here what we can see, or what we can do, is clear out our Zap session. But we've got a plugin that we've released for Zap that basically lets us go and import these endpoints. So we connect to the ThreadFix server. We tell it the application we want to pull the data for. Give it the base URL. And it pulls in those endpoints. And so what we see here is that we've found pages that we would not have otherwise found, like this admin page, this admin.jsp page. If you crawl the application, you're not going to find that. There's no links to admin.jsp in the application, but the application exposes that page. Similarly, if you look at a number of these debug parameters, if you crawl the application, you're never going to find a reference to those debug parameters, right? Because it's not, it's a debug functionality. It's not supposed to be there. But if you pass in that debug parameter, the application is going to do something based on it. I once did some work on a Cold Fusion application where any page in the application, if you passed in a parameter named D, it would take the value of that parameter and try to delete the order with that number. So if you passed in D equals 1,000, it would try to delete order 1,000. Right? Like, I don't know why the application did that. I think it was like a convenience feature, right? Some sort of administrative convenience feature that had somehow gotten cut and pasted into every page in the application. But again, this will help to identify situations like that so that you're exposing those parts of the application to fuzzing. And again, what we're going to get here is a much more thorough scan of the application because we're getting all the URLs. And so if you have landing pages in your application that maybe link back into the application but nothing links back out to them. Again, if you have this hidden debug functionality, if you've got auto binding turned on, this is going to let the application scanner know here are additional pages you need to look at and here are additional parameters that you need to fuzz if you want to get thorough testing of everything there. And yeah, that's the icon I need. There we go. And similarly, what we can do is connect to ThreadFix and pull data about the endpoints. And even with just a dynamic scan, we map back to lines of code, and so we can put these markers. We can put these markers in the line of code. Again, with the full static analysis results, you're going to get better. You're going to have a better user experience if you can show the entire data flow and control flow. But at the very least, with the dynamic scan results sitting on top of this hybrid analysis mapping model, that lets you map back to individual lines in the IDE, which gives the development team a head start. And so the idea here is, how do we put developers in the best position possible to fix these different vulnerabilities? There we go. Let's see. Okay. Any questions about those integrations? And so right now we support on the scanner side, we support Burp and Zap with plugins, and on the IDE side we support Eclipse and IntelliJ. We're working on support for ASP.NET MVC, and out of that we'll also be building a Visual Studio plugin as well. And again, just looking at the relative level of effort to construct those, the parsers for the different frameworks, it's something that takes a couple of days, to kind of get something first working, and then you refine that with additional testing data from there. So what's next? We actually started a phase 2 with the Homeland Security folks, which is great. So that's allowing us to add support for additional frameworks like ASP.NET. We're looking. We've done a little bit of work with Python, Django. We're looking to add struts, JSF, or Ruby on Rails, and working on Visual Studio. Another thing that we're doing that I think is pretty exciting is we're going to expand the model, the attack surface model that we're building. And we're going to add concepts of authentication. Which pages do you have to be authenticated for versus not? We're going to add the concepts of authorization. For these pages, you need to be in this role. And we're going to also build out additional injection points. Right now, we're only considering get and post parameters as well as path parameters in REST-style URLs. We're going to be adding cookies and other HTTP header injection as well. And what I think that's going to let us do some really interesting stuff where, based on that model, if you have a static scan result that says, I've found 1,000 cross-site scripting vulnerabilities in your application, if you also have a filter that you can apply to say, but these URLs are the ones that you can get to when you're unauthenticated, that allows you to start to triage data more quickly by saying, I've got 1,000 results that I'm worried about, or I've got 1,000 results, but only 100 of them can be accessed from an unauthenticated user. Therefore, I'm going to focus on remediating these 100 first because these are the ones that I consider to be higher risk. And so, again, I think there's some pretty cool analysis that you can start to do if you've got a structured model for what an application looks like. What's the attack surface? What are the injection points? Which portions require authentication or certain types of authorization? Because from that, you can start to make decisions. And that's, again, a big push that we've seen in a lot of organizations as they try to scale is, how do we get, how can we better manage this giant volume of data that we've got? I think I'm just about out of time here. But again, this is stuff you can download from GitHub. And feel free to reach out to me if you've got any questions. If you want to add support for something, let me know. And I don't know, do we have time for questions now? Or are we done? Done. So I will be around outside. If you have any questions, please feel free to track me down. Thank you all very much.
I have a dual role. I spend most of my time doing security testing of web apps, and then I also do about 40% of the time I'm doing development work. And that was kind of the motivation to creating the BDD Security Framework, which is taking development tools and development techniques for testing and applying those to security. So security is playing catch-up again with development practices, in this case DevOps. And although there's a lot of hype around DevOps, I think there's a lot of real value there. And there's a lot that we as security practitioners can learn from what is happening in DevOps. I say we as security practitioners. Who's in a security role? Hands up. Who's in a development role? Good. Who is in neither of those roles? What role are you? Test architect, very good, very good. So it's good to see a good mix of the two disciplines. And what I'd like to do is frame DevOps as a means, right? It's the means to an end, but not the end in itself. DevOps gives us the ability to use continuous delivery and continuous deployment. And what continuous delivery and continuous deployment say is that instead of building our software by batching up all of our features into a release, and then taking that release and putting it through the testing process and eventually deploying it, why don't we release individual features? So as we finish a feature, we take it through the same process and we deploy it into production. This means we don't have to wait for everything to be completed before we start seeing real value from it. We can get our features into production much faster. So this kind of explains the relationship between DevOps and the development practices. If you're doing agile, vanilla agile, or continuous integration, as a developer, you're working in your restricted development environment. So you're building your code, you're building your features. Once you've built up your features into a release, you may run it on your continuous integration server, which runs automated tests on it. You say, well, this is working in development now. And you take that software, hand it over to someone else, and it's then their responsibility to build a testing environment, deploy your code into a testing environment, run more extensive tests on that code, and then eventually deploy it into production. So there's a distinct handoff process between development and ops, or development and the rest of the organization. And to do that, you don't really need DevOps. You don't need tight integration between developers and operations, because you're just doing a handover to them. But if you ramp up to continuous delivery and continuous deployment, now, because you're releasing an individual feature that has to go through quite an extensive testing process, you have to talk with ops, and you have to have more automation in the process so that you can deliver not just code, but you're delivering code plus a working testing environment that you've built through automated configuration. You're running more extensive automated testing against your new feature, and then in the case of continuous delivery, you deploy into a pre-production environment, and there's still some manual process that has to go on to deploy it into production. Or if you're doing complete continuous deployment, it takes the next logical step and says, we want one entire continuous process that will give us feature going in one side, and we deploy all the way into production on the other side. And the continuous delivery guys talk about a pipeline. So it is this one long continuous process. Your requirements go into the one side. Those requirements get turned into tests. Tests get turned into code. Code gets deployed into further testing environments. Tests run against those, against that code and against those environments, and then finally deployed into production. So DevOps gives us the ability to operate that pipeline. DevOps is currently the only way we know that we can run this continuous delivery pipeline, where we're delivering code and environments all at the same time. So when dev and ops are working together in perfect harmony in a DevOps environment, you can now reach these kind of numbers, where Amazon is deploying into production every 11 seconds, a new feature into production every 11 seconds. Etsy, gov.uk, multiple times per day. So I think the question for security is quite clear, right? If we have this ability, if we can deploy at this rate, How can we do this securely? And I think the typical security team's answer would be something more along the lines of this. Forget about continuous deployment. I can offer you continuous annoyment, right? There's no way we're going to let you deploy into production every 11 seconds without doing security testing. And we simply cannot deliver security testing every 11 seconds or 25 times a day. And why is this? So this is typically how we would approach application security from a traditional standpoint. We'd have our central component are our security requirements. We derive those security requirements from organization-wide security standards and a threat model for our application. Combining those two things, we decide what controls we need in our application. Some of those controls are going to apply to ops. Other controls are going to apply to the development team. And that's usually a dead document type of operation, right? It's written in Excel or PDF or Word or something like that, handed off to developers, and I know what happens with that document. It gets thrown away or it gets put into the bottom drawer and never looked at again. So once we say dev does implement the requirements we've asked them, and so do ops, we then have our security processes which verify that we have implemented those requirements. And those are typically manual processes. For example, we have the security team who would run things like scanners, static or dynamic analysis tools. And although those tools are automated, running the tool isn't automated. It's still a human who goes and initiates an ActiveScan or goes and initiates an AppScan, interprets the results, decides what to do with it, and then hopefully maps it back to our requirements, saying, well, these vulnerabilities now say we've not implemented these specific requirements. We would then rely on manual application security testing. So we get expert testers in, come and test our application, tell us what's wrong with it. For bonus points, we would offload some of our functional security requirements to the QA team, right? There's no need that we need specialist security knowledge there. We can get the QA guys to test some of that for us. So this model doesn't really fit into a continuous delivery pipeline. So if we want to learn from DevOps and how DevOps is doing the process, we don't have to start from scratch, because security testing is really not that special, right? We're doing testing which is very similar to what quality testers are doing. We're doing slightly different tests, different types of tests in a different way, but in essence what we're doing is quite similar. So we can look at where quality testing is currently applied in DevOps, and we can piggyback security testing on those same processes. Continuous monitoring is something else that DevOps is quite famous for, and I'm not going to go into that at all, because it's a whole topic on its own, other than to say that the OWASP AppSec project is probably a great way to get continuous security monitoring built into your application. And then extensive automation, and particularly automated tests to verify that what you're doing is correct, and that's what I'd like to focus on next. And when I say security testing, I'm talking about more than just security scanning, right? Scanners find bugs. They find implementation flaws. But scanners don't find things like functional security. They won't tell you that a user account or that you have an account lockout on your login function and that's not working anymore, or that the captcha that you're meant to display on your self-registration page isn't being displayed anymore. Those are all functional security things that I want to test, but a scanner is not going to find it for me. Another conceptual difference is that tests have an expected outcome. Tests can pass. You give it a specific passing qualification, right? So you can assert that if this is the case, then the test passes. Otherwise, the test fails. Scanners just have a silent response, right? If a scanning result is going to be a positive response, it just gives you back nothing. Then you say, great, I got back nothing, awesome. But there's no real passing criteria built into a scanning run. And if it's a human operating the scanner, that passing criteria is stored in the human's brain. Like it's the operator saying, I've got back these results from the scanner. Some of them are important, some of them are not. I know these are false positives, and therefore, okay, this is fine to go live. I'm not going to act on these vulnerabilities. So that logic is not stored in code anywhere, and it's often not documented anywhere either. Next up, if you're doing test-driven development or behavior-driven development, then the tests can become a direct substitute for your requirements. This means you can move away from this dead document model of requirements, where your requirements are written on a piece of paper somewhere, and you have dynamic requirements, requirements that can verify themselves. So if you at any point want to know, where am I standing with my requirements? Simple, run my tests. What do my tests tell me? If any of them fail, I know those requirements are not being met. And finally, tests are treated the same way that code is treated. So they're stored in source code control. You know who changed it last. And if something breaks, you can go and track back and see who changed what at what point. So this is a first stab at writing that type of security test, right? This is a non-functional security test. We want to verify that the session ID after login is different to the session ID that you were given before login to prevent session fixation attacks. So using JUnit and Selenium, we can write something like this. So first up, Selenium, get a particular URL. Selenium, everybody familiar with it, it's a browser automation framework. It uses a real browser. You can give the browser commands and it'll go and navigate the app for you. So selenium.get a particular URL, then read the session, get the login page URL. So I'm reading the login page, I'm not logging in yet. Once I've got that page, if the app is setting a session cookie already, read that session cookie. Then log in. And how do we log in? You tell it through Selenium how to log in. Find the username field, enter the username, find the password, enter the password, click the login button, and you're logged in. Now go and read the new session cookie that has been set in the browser. And then my passing criteria. Assert that the after login session is not the same as the pre-login session. And we will then know whether our session cookie has changed. So this works, but there are a couple of problems with it, or architectural problems. The first one is that we've got two separate domains mixed up here. We've got our navigation logic for our app and our security requirement that we want the session ID changed, all mixed up in the same bit of code. So changing the session ID after login is a common requirement. I want this to apply to all of my apps. So I've got 200 different applications. They all log in slightly differently. But now, if I wanted to apply the same test to all of them, I'd have to write 200 different tests to be able to deal with all the different login scenarios. The second one is a bit of a technical problem with Selenium in that the Selenium folks are geared towards driving the browser itself. So through their API, they don't expose HTTP at all. Getting the cookie is as low level as you can get with the Selenium API. You can't even get the HTTP response code using Selenium. You can't read HTTP headers. And all of those are quite critical things for security tests. And then from a DevOps point of view, if we wanted this test to apply for our DevOps team, that means we want our developers to understand it, our QA people to understand it, our operations team, our security guys, and even the project manager. That's the whole concept behind DevOps, is we want the whole team to collaborate and work on the same problem. And unfortunately, this is only understandable by whoever understands JUnit and Java. So it excludes a large part of our team. And solving some of those issues was the idea behind the BDD Security Framework. So it's an open source framework you can download from GitHub. It has a couple of features, most important of which is that the tests are written in a natural language. They're not written in code, which means everybody can understand the tests. It includes automated functional tests, non-functional tests. It wraps security scanners in tests. Currently, ZAP supported, Nessus, and as a simple port scanner built in. This is that same test written in BDD Security, in English, basically. The only requirements are to use a given, when, and then format when you write your specification. So we issue a new session ID after authentication, And given the login page, means the browser goes and gets the login page, and the value of the session cookie is noted when the default user logs in with the credentials from this text file, and the user is logged in, then the value of the session cookie issued after authentication should be different from that of the previously noted session ID. So this is understandable by whoever understands HTTP and cookies can understand what this specification is. Each one of these lines is backed by code. So there's code at the back that's running the appropriate bit of functionality to verify this, which means this whole thing is executable. So now we have a real good substitute for specifications in a document written in English. We now have the same specifications. We can write them in English, but at the same time, they're executable. And the other important thing is that you would write this before you build your app. It's a specification. It's a requirement. So the first time the developers realize they need to change session IDs after login is not when they get their scan results. It's before they start building the app, so they can build it right from the start. So a bit more about the framework. It uses Selenium, which means it can use lots of the Selenium drivers. It can use Chrome, Firefox at the moment, Safari, even iOS Safari as well. And it uses OWASP Zap. So OWASP Zap forms the cornerstone of the framework because we can't get HTTP information from Selenium. So we pass everything through Zap, and we can read HTTP traffic through Zap. And of course, we also use Zap to do the scanning. So test must be understandable, written in English. It fits into a development workflow. So you can run the test in an IDE. You can run them on the command line. You can run them on your continuous integration server so that they run every time new code is uploaded to a CI server. And then the output is also interchangeable. It produces JUnit output. So your other tools that depend on JUnit can just read those results. And it also produces HTML output. Then the logic of the tests is independent from the navigation code. So this was one of the goals, right? We want to use the same set of tests against different applications. And we just want to change the navigation logic in one place. We don't want to have to go and change the tests. So by doing that, the framework ships with a bunch of pre-written security requirements, kind of like a middle-of-the-road, basic set of security requirements for every app. Comes with the framework. You just need to tell the framework how to navigate your application. So let me show you how this works. So the app I'm going to test is a very basic app. Log in with Bob, password, and you can view your tasks in this app. Click on your tasks. You can view your profile, and that's about it. So very simple, but it supports login, it supports logout, and supports doing something behind the login. So if we wanted to test this using the BDD Security Framework, first thing you would do is check out the framework, and it comes in this format. You'll get all the code for the Java bits as well as the stories. And these are the pre-written security stories that come with the framework. So yeah, in JBehave lingo, a story is like a test suite, and a scenario is a test. So a story contains a load of scenarios. You can either run individual scenarios, or you can run whole stories or entire groups of stories. So if we look at the first one, which is AppScan, and this is simply wrapping Zap in a testing format. So we're going to use Zap to do scanning. If we look at the first one, SQL injection scanning. The given when then is there, as we saw with the previous example. The complication here is that we have a given story. You'll see it at the start there, under the meta, there's a given story of navigate app. So we're saying, given story says, go and run this story before you go and run this particular scanning. And what we're trying to do here is we want to navigate the application before we go and scan it. So let's have a look at navigate app. Navigate app says, given a new Zap scanning session, and the page flow described in this method is run through a proxy. and the following URL regular expressions are excluded from the spider. So we can add expressions here to exclude from the spider. It's just a text file. We can configure the spider, maximum depth of 5, 10 concurrent threads, and we want to scan these particular URLs. So the base URL is something that's configured in the configuration file, which I'll show you in a second. So after we've done that, after we've navigated the app, we can then start doing our scanning. The scanner says, given a scanner with all the policies disabled and the SQL injection policy is enabled, we set the attack strength to high and the alert threshold to medium. So each of these is backed by Java, and I can go to each of these. And you can see that the attack strength, for example, is using a parameter here. So we can pass in the attack strength using this JBehave format. So we can change this to medium, for example. So from a DevOps point of view, you don't have to be a Java developer to be able to configure how you want Zap to work. You can just change it in the specification. Then we'll run the scanner. Next, we will then look at the false positives described in this text file, and we'll remove them from the results. And then we would expect that no medium or higher risk vulnerabilities should be present. So what we've done in these two lines is we've asserted our expectation. So now that process that was stuck in a human operator's mind saying, ignore these false positives and stop the build if there's a high risk vulnerability, we've now coded that up in a document that's self-verifying. So the false positives table is just a text file. It's, again, you would add the URL of the false positive here, and you just use a pipe symbol to put the parameter, another pipe symbol, the CWE ID, for example, like that. And you would add your false positives there that you want Zap to ignore. Right, so that's an AppScan. You'd also have to configure a config file. This config file says we're going to use two Selenium drivers to test our application. One of them is going to use Zap for the tests that require access to HTTP, and one of them is not going to use Zap because it's going to be a bit faster, and we don't need HTTP for some of the tests. So we just define which drivers to use. In this case, I'm using Chrome for Mac. You can use Firefox as well. We define the base URL for our application, so just the common URL from which all the other URLs are based off of. And then, importantly, we define the class that contains our navigation logic. So all our navigation logic about how our app works goes into this class called OWASP demo, which doesn't exist yet. So let me just make a copy of that. Okay, we then define some other things, where the session ID is stored. We define at least 2 users from every role in the app. So we tell the framework who the users are. There's Alice, what her password is, Bob, and admin. So before we can run any of our tests, we now need to go and create that navigation class. We extend web application base class, which provides us with Selenium and some other convenience methods. And if you'll remember, the navigate app story required a method called navigate, which told us how to navigate our app. So we'll create a navigate method like that. And now to just do some basic navigation in the app, we need to give it valid Selenium. And because we want to save time, we'll use the Selenium Firefox IDE, which will record our activities on the app and convert them into Selenium commands, and we can copy and paste them into the file. So if I just want to do login as Bob, password, login. I'll keep it simple for now. So Selenium IDE has recorded those, and as long as you set your clipboard format to Java JUnit 4, you'll be copying valid Java here. So I've copied that, paste, and I've got valid navigation code there. Just need to change this base URL. Done. So at least now we will go, when we run this, the scan, it'll first spider by doing this, run the spider, then run the scanner, and give us our results. So let's run that story, AppScan. We can run this individual scenario from the IDE. So it starts up and it starts 2 browsers. Ooh. It's one for you, Simon. Right, so also in the config file, don't know if you saw that, there's the proxy address for Zap. So if we tell the framework where Zap is running, I've got Zap running in the background at the moment, listening on port 888 with a fresh, new, bug-free instance. And let's try run that again. There we go. So you can see it's running some of the tests in this browser. It's logged in. And we'll see now it's already run the spider, and it's now running the scan. Scan is done. And we have a test failure. We expected 0 medium risk vulnerabilities, but we got 1. Here's SQL injection in this particular URL, in this particular parameter, and this is the CWE ID. So if you manually verified this was a false positive, you can take this data, stick it into the false positives file, and now you won't be alerted with this for future tests. Okay, so that's the first type of security test we want to run, is just wrapping a scanner, and we do the same thing for Nessus. Right? So we log into Nessus. We use a particular policy that's already been defined. We define our targets. We can add them here in text to the story. Run the scanner, remove false positives, and then set our expectation that we want no severity 2 or 3 or so many higher vulnerabilities. And the same thing for port scanning. And we'll use the same approach for any other security tool we want to pull in. Just wrap it in a test, put the false positives in, and we can run that scanner. Right, so that's scanning. That's one type of thing we want to test. We also want to test functional security. So things like test that passwords are case sensitive. Test that the login form is presented over an HTTPS connection. Test that a captcha is displayed on so many authentication attempts. Or test that the user account is logged out after so many, or locked out after so many failed authentication attempts, and so on. So we've got a couple of authentication stories. We also have some session management stories which do similar kind of things. When I log out of the app, I want actually to be logged out. I don't just want the cookie to be removed. It must be logged out on the server side. So these are, again, functional security things I want the framework to test. So in order to test these, we need to do a bit more work, because we need to tell the framework how to log in. Although we've told it how to navigate, and navigate happens to be logging in here, we need to tell it explicitly how to log in and how to log out. So it's got some predefined interfaces, I log in and I log out. Which require us to implement these methods. So firstly, we need to tell it how to open the login page. We've already done that. We'll use that. We need to tell it how to log in. Well, you'd just do that. And we want to log in with any set of arbitrary credentials. So user pass credentials. Get username and get password. So now we can log in with the framework, and the framework already knows who the users are because we configured that in the config file. So now we can log in as any arbitrary user. Is logged in is an important method. We need to tell the framework how does it determine whether a user is logged in or not. So this is something you would have to test out of band with the framework and work out. In this case, if you got this URL, for example, the task list URL, when we see the word welcome, we know that we're logged in. If we don't see the word welcome, we know we're not. So we can use that to write our isLoggedIn method. Driver.get get that URL, and if driver.get the page source contains the string welcome, then return true, else return false. And finally, tell it how to log out. In this case, it's quite easy. It's just a single URL we need to get. Let me just verify that. Yeah, user logout. Good. Right. So now the framework knows how to do a lot more things. Our navigate method becomes simpler. Open the login page and log in using any set of credentials. And now we can run things like the authentication story. Fires up the two browser instances and runs Selenium tests against them. Done. And we have our results. We can either read them in the IDE or we can read them in HTML. So here we can see which of our requirements have failed. Passwords happen to not be case sensitive here. The login form is not presented over an HTTPS connection. It should have, we expected HTTPS, we got HTTP, and so on. And the user account was not locked out after 4 incorrect authentication attempts. Right, so there are many more functional and then also non-functional security requirements defined. So we have things like HTTP headers. Verify that our app is using the right security headers. Do we have strict transport security enabled? Do we have anti-MIME sniffing header inserted? And we have SSL, for example, test for heartbleed, test that we support TLS 1.2, et cetera, et cetera. So again, the difference between verification and tests is that these tests you would give to your ops guys and say, build me a server that meets these requirements. And they build it like that, not get the results after they've built the server. Right, so I think one of the more interesting types of tests or functional security tests you want to run is access control. You want to test that Bob can't see Alice's data, right? And that's something that scanners typically aren't really good at finding because they don't have that conceptual knowledge of the application. But we can program the framework to understand that. So with our app, for example, every user has a profile. And they should, of course, only be able to view their own profile. So to configure an access control test, the framework requires 3 things. The subject, who's logging in this case, Bob. The action that Bob performs, in this case, view his profile. And then the sensitive data that he sees when he views his profile. So we can pick one bit of data there that's unique to Bob and make sure that no other user can see it. So we configure this again in the navigation class. We create an arbitrary method name. We'll call it view Bob's profile. And we will get the base URL. Oops. So we'll get this page, and then we'll click on the profile link. How does Selenium click on links? Well, we can just record it. Click. That's what a link click on profile looks like. And that's it. So we've defined one of those three. We've defined the action we perform. And now using an annotation, we tell the framework who is allowed to perform this action. In this case, only Bob. It accepts an array here, so you can put other users who are also meant to see the same data. And we specify the sensitive data that only Bob should see when he clicks on that link. So let's just pick his first name, Robert. Okay. So the framework now has everything it needs to perform an access control test. It knows how to log in. It knows what action to perform in Selenium. And it knows who the other users are of the app. It's user Bob, Alice, and admin that we've configured. So we can run the authorization story. And it's running its tests, and done. So the access control story is a bit unique in that the very first scenario is this kind of a setup scenario. So the first time it runs, it goes and first checks that what we've configured is correct. It creates an access control matrix automatically from the data that says when user Bob logs in with password and he performs the action view Bob's profile, then he should see the sensitive data somewhere in the HTTP responses. So that should always pass if we've configured everything correctly. And then it builds the inverse access control matrix. So it says, if user Alice logs in and then performs the view Bob's profile action, she should not see the word Robert in the responses. And it goes and recreates the scenario for each of the users that has been defined in the config file. So we can automatically test for access control. And we can see in this case, we have an access control failure in that Alice can see the word Robert if she performs the action view Bob's profile. And as a human tester, we can see this is one of those basic access control problems. There's just a parameter there that any user can see any other user's data by changing the parameter. But the framework went and found that for us. Right. So since we're using standard technologies here, we can run from the IDE, we can run from the command line, and in a good example or in a good practice scenario, we would also want to run this on our continuous integration server. So this is from the point of view of a developer changing a web application with integrated with Jenkins and integrated with BDD Security. So the developer goes and changes some code. Say he's changing something in the web application. Here's a Grails web app. Changing how to do queries, changing how to get the user ID. So the developer then goes and commits his code to Git. So in Jenkins, we have two jobs. The first job is the ropey tasks job, which is to build the web application. So the first job is continually monitoring Git. And if anybody submits new code, it goes and pulls down the code, builds the application, and deploys it onto a test server. The second task, it then checks whether the first is finished. Once it's finished, it's going to go run the BDD security tests against the deployed application. So all of this is entirely automated. I'll be clicking around on the screen just to show you what's going on in the background, but this doesn't require any user interaction whatsoever. So here we see it's building the web application itself and deploying it to Tomcat. So it's deployed, and now it calls the next task, which is to run the BDD security tests. And in this case, they're running on a Linux box that has X enabled and an actual browser, but you can run them headless. You can run Zap headless as well, so you don't need to actually run a proper browser. This is massively speeded up. It doesn't scan this fast. So running all the non-functional, functional tests that are included, all of the stories.
How long will it actually take, like, for it to run?
So for this simple app, it takes about 5 minutes.
Like a realistic scenario, like?
Yeah. But remember, this app's quite simple. There's only like one form to scan, so it's, you know, the more complex your app. The big bottleneck is going to be Zap scanning. So typically, as fast as you can do Zap scanning, you would do this type of scanning. So we get a report immediately of our test results. We have 24 failures in total, and 3 of those are new failures caused by the new code commit. And we can see what they are, and Jenkins will take us, give us more information about those failures. Since they are JUnit results, we can get the same message that we do from the IDE. We found a cross-site scripting vulnerability. We found an authorization vulnerability, an access control flaw. And because Jenkins integrates nicely with GitHub, and we happen to be using GitHub, we can go directly to the code that caused this problem. And we can see which commits have caused these new 3 failures. And we can look at the plain HTML reports as well from within Jenkins if we wanted more detail about exactly where the problem was. Where is that cross-site scripting vulnerability? Right, so there are some limitations. The access control tests, for example, are not CSRF aware or anti-CSRF aware. So if you've got CSRF tokens in your app, it's not going to be able to do the automated access control tests. That's something I'll be looking to add quite soon. Email actions are not implemented. So if you want to automate self-registration or unlocking that requires email, you can't do that at the moment. You have to write that yourself. Yeah, test maintenance. Because we're relying a lot on how we're navigating the app, it's a really good idea to put logical tests in your navigation code that fail if you see a page you're not expecting to see. So if in your navigation code you're getting to a page that you're not meant to get to, assert a failure there, say something is wrong, so that the test fails and you know you need to change something, rather than just having it silently continue and you get false results. So what we've done is we've moved from this model where we're using dead documents as the central part of our security architecture, and we're moving to live self-verifying requirements. We have requirements that can verify themselves. We can run them at any point and say, what is the security of our application looking like? And it can tell us what fails and what is passing. We still have these processes, but now they're wrapped in tests, so we can run them whenever we like. It doesn't cost us anything. And we have documented what our false positives are and what our acceptance criteria for each of those tools is. Some references. So some additional tools that you could strip out from the framework if you're just interested in doing specific things. I do want to mention 2 other frameworks that are quite similar to this. Gauntlet, which is written in Ruby, and it's purely a test wrapper. So it wraps Nmap and it wraps a couple of scanners. It doesn't do any functional tests. And then Mitten, which is recently released by F-Secure, is written in Python, and it uses Burp to do a similar type of thing. Again, it's purely scanning. It's not doing any functional, non-functional tests. Guess we have time for questions? Sort of? 1, 2? Yes. OK, 1 question. No? OK, if you have some, I will be available after. Thank you.
is about ActiveScan++, which is a Python plugin for Burp Suite. And it's also about the new opportunities that are associated with integrating vulnerability scanners into intercepting proxies. So first off, about me, the bio in the program is actually about someone else. So I'm a security consultant at Context Information Security. Spend most of my time web application hacking. And in my own time, I also do a lot of vulnerability bounty hunting. And I found that the most effective, or at least the most enjoyable approach to that, is to look for the issues that other people haven't bothered looking for, that they haven't thought of. And to that end, I've done a fair amount of research into host header attacks. So this talk is going to cover this approach to vulnerability scanning, what the difference is from a classical vulnerability scanner, where you just run the scanner and it crawls the site and then tests everything in an entirely automated way and spits a report out at the end. Then I'll talk about the specific techniques that ActiveScan++ uses to find issues and how the underlying issues work and how to practically exploit them once ActiveScan++ has found them. And finally, I'll talk about some current research into finding vulnerabilities in a more generic way, more oriented towards finding unknown and interesting vulnerabilities. So first off, with a classical scanner, you only really have one goal, and that's finding complete vulnerabilities and reporting them to the end user. With a proxy plugin, you are integrated into the manual testing process, and as such, there's a wealth of information which wouldn't be useful to an end user, but is invaluable halfway through a test. For example, if a scanner finds that it can inject HTML syntax characters, but for some reason can't get any HTML tags in or any script tags or the like, then it can't really do much useful stuff with that because it can't report it as a vulnerability because as a scanner it doesn't have the capability to prove that it's a vulnerability. But a manual tester may well find that information very useful because they could probably bypass whatever's going on that's preventing HTML tags from being injected. And another example of information that's almost innocuous in a final report is version numbers. They aren't very useful at the final stage. I mean, it's worth knowing if something has known vulnerabilities, but if you find out that something is running a version of PHP that has registered globals turned on by default when you're halfway through a test, then that could seriously affect the techniques that you use to test the application. You would start to look at things like guessing parameter names and the like. So there's the software version reporter extension currently in Burp, which does that. It's also fundamentally a lot easier to write a scanner as a proxy plugin because you're standing on the shoulders of the manual tester. All of these issues which typical scanners run into and work around as best they can and put a lot of effort into dealing with are avoided. Everyone who's run a scanner has probably found that they find a contact us form and then submit it several thousand times and take out an email server somewhere. And even if scanners are advanced enough to recognize something like that, I don't think any can negotiate something like a checkout process on a live site that involves adding something to your cart and supplying real credit card details, actually buying an item. They aren't going to be able to they aren't going to be able to do that, but the manual tester can, and that they can guide that and avoid all of those problems. As a burp plugin, this tool, there were a couple of issues. Burp is not open source, so it's entirely API bound in what it can do. There are various cases when there were things that I would like to implement that weren't possible because the API was too restrictive. However, Z-attack proxies, proxy plugins obviously wouldn't have that issue. So those two key differences redefine what information is useful and how easy it is to get that information. And the result is that it's very easy to find serious issues without writing much code for it. For example, that's the majority of the code that I wrote to detect when eval is being called on user input. And it just sends some payloads, times the responses, and sees if they take longer when I tell the server to sleep for longer. And it honestly took longer to write those payloads so that they would work in as many contexts as possible than it did to write the actual code. However, ActiveScan++ is really an opportunistic tool looking for issues that aren't detected by burp's built-in scanning capabilities and that are tedious to find manually, and these tend to be more esoteric attacks, such as those using the HTTP host header. The point of this header is to tell the server which virtual host on that server you want to talk to, like which application on that IP you're communicating with. And historically, this host hasn't been used for attacks very much, hasn't been tampered with, and people tend to trust it. For example, that's some code that I found on GitHub, and it shows that the developer looks at the host header, sees if it's localhost, and if it is, they think this must mean it's being accessed from the local box. So it must be a development environment, and it's safe to enable debugging features and the like. The reason it's seen as being fairly secure against attack is because the most obvious thing, the reflected cross-site scripting style attack is not really plausible, because we can't make our victim send a malicious host header in a way that's useful. So that just doesn't work. We can trigger a tainted server state, but we need some kind of side channel to get that state to the target. The easiest such way that I found is using site's password reset functionality. If a user says, I want to reset the password of this person, and sends a malicious host header, then the application will take that host header and use it when they generate the password reset link. And the victim will receive a link which, if they press it, will communicate their secret key to the other user, giving the other user control over their account. That issue has affected a wide range of web applications and frameworks, primarily because it's surprisingly difficult to find out where your server is really located. So sites fall back to using the host header. The dotted line on that diagram shows an alternative attack where, if you're lucky, that application will place the host header in an email header, and then you can simply CC yourself on the password reset email. And you can, in that case, you can generally also attach a zip bomb, which the victim's email, like webmail provider will recognize and drop the email silently, so they never even receive it. However, that attack generally does rely on the target clicking on a link in an unexpected password reset email. cache poisoning is much more fun. Simply, if they've got a poorly configured web cache, then when you send the request to the server, your response, which has the malicious content in as per like a standard reflected cross-site scripting thing, gets cached by the web cache and served up to everybody else. So with a single request, if it's well timed and well crafted, then an unauthenticated user can gain complete control of the homepage of their target website. This attack is quite tricky in practice. On standalone caches like Varnish and Squid tend to look at the host header when they're when deciding whether to cache a value or not, because they might be in front of multiple applications. It was possible to trick Varnish, however, by sending 2 host headers, because Varnish would look at one host header, and the backend application, if it was Apache, would look at the other host header. The most effective target for this kind of attack that I found is the built-in caching systems in Joomla and Typo3, and I expect in similar systems, because they're part of the application. They don't look at the host header, so they assume that it must be safe, or the request would have never reached the application. So in order to detect this kind of vulnerability, you could write something that combined the many techniques and actually try to find a cache poisoning vulnerability by performing a cache poisoning attack. I tried that last summer. It's extremely difficult and isn't very effective most of the time. However, simply by sending a few selected requests and seeing whether our malicious host header is reflected in the server response tells us whether that application is using the host header, which is a very good indicator of whether it's vulnerable to one of those techniques. So the first such request is perfectly simple. Just send a bad host header. It's important that the referrer always matches the host header, because applications often check to see they match as a cross-site request forgery defense. The second request uses an absolute URL in the request line, and that's necessary when the application that's being targeted isn't the default virtual host. So Apache will see that request line and give that precedence over the host header and route it to the correct application. But the application will often actually look at the host header itself. Finally, in some cases, such as when something is hosted behind Cloudflare, you just can't get a request with a malicious host header to the target. However, the X-forwarded host header is widely supported and used instead by many frameworks. So that comes in very useful. Okay, around a month ago, Typo3, which is a popular content management system mainly used by businesses, I think, reported this vulnerability. And as you can see from the advisory, it's slightly vague. It does sort of imply that password reset poisoning is a plausible attack. So let's have a look at this. Okay. Proxy. Need Firefox. All right, so okay, that's a default typo 3 installation with the addition of a username and password prompt. And sorry?
You can do screen mirroring so that you see the same.
Yeah, this should work out okay, I think. Yeah, so if I refresh this, catch the request in burp, and then run and then run an active scan of that, then we should quickly see that there's a host poisoning. That's interesting. Okay, I've no idea what's happened there, but I have a video. So, right, default typo 3, and I'll just run an active scan on that. And so that will just send those 3 requests that I showed earlier, and see if any of them get reflected in the response. So we can see here it's found this issue, and it's attached several requests. That's the standard request and response, and that's the attack request. So we can see there that the input that we gave in the host header has been reflected in the response, which implies that this is vulnerable to host header poisoning. So first off, if we take the base request and then change the host header, we can see that we get a different application, which is just a test page because it hasn't been configured. That's because it's not the default virtual host. But if we then specify an absolute URI, then we can put whatever we want in there, and the application will use the host header, but the server will use the request line. So then it's simply a matter of requesting a password reset for someone and using that technique. And then, so we need control of a user account on the system in order to test for this issue properly. But if we didn't have one and had a list of usernames, we could generate a large number of emails like that and see if we got any hits on our site with password reset tokens in. So there we can just see the resulting email with the poisoned link in it. Okay. Now, let's see if we can do a cache poisoning attack. If I do. Okay, great. So, pretending that my scanner already found that issue, we know how to get a request to the server with a bad host header. like this, right? So we can put whatever we want there, and it gets reflected in the response, right? So when testing for cache poisoning, the key thing is to make sure that you aren't getting cached responses, because if you're receiving a cached response, then the issue really isn't visible to you. With most applications, you can do that by doing a force reload in the browser, which adds a header which says, "Don't give me a cached response." Typo 3 doesn't respect that header. In order to do this in Typo 3, what you actually need to do is add a parameter called noCache and set it to 1. So if I send this now, then we can see that our input has appeared in more places than it previously was, such as in that base tag. And as is very common with that header, it hasn't actually been HTML encoded, so we can directly inject scripts here. This isn't necessary to perform an attack because it's the base tag, so there are plenty of other things that we could do here, but I'll just use this for simplicity. So this is the response that we want to get cached, and in the case of Typo 3, I've found that the best way of doing this attack is waiting for the cache to expire and then sending our request. In this case, I'm going to trigger the cache expiry so that we don't have to wait. So that should mean that the cache has been cleared. So I can send this response, and that still won't get cached because of this parameter. But if I change that to 0, then it should get cached. So from now on, whatever I put here, hopefully, we can see our injected HTML. And that means if I load the home page as a normal user, located anywhere, because this is cached on the server, then our injected content fires. So we've got full control over that. Okay, shifting back. So no talk about the host header would be complete without mentioning DNS rebinding, a much older vulnerability using this header. This is based on the fact that the same origin policy is all about host names and not IP addresses. So an application can hop between different IPs while remaining on the same origin from the browser's perspective. So in brief, we can serve the user some malicious HTML, tell them to cache it, and then tell them that we are now located on localhost. And our cached HTML and any JavaScript in there will thus have access to localhost. In effect, with this technique, we can proxy through the user's web browser to access internal resources. This attack was partially fixed by browsers by DNS pinning, which just means that browsers won't believe you when you say you've moved like 2 seconds after you said you were in a specific location. However, when browsers are restarted, they do re-request the location, and they've said that they can't fix this for usability reasons. Servers may really move, and therefore they can't fix this anymore. It's the responsibility of the server and the application to fix this issue. And this means that as testers, if this issue is relevant, we should flag it. And in some cases, quite close to home, it's very relevant. Burp Suite Professional has a web interface which is only accessible on localhost and lets you view all of the traffic that you've proxied through Burp, whether SSL or not. And this interface has no authentication on it of any kind. So up until about up until a couple of weeks ago, it was possible to gain access to the full history of any Burp user by using this technique. It's now been fixed in the professional version, at least. To address these issues, it really boils down to making the host header as trustworthy as people assume that it will be. And that can be done by using a whitelist of trusted hosts. That's how the major frameworks have dealt with it. They allow wildcards, which can backfire, aside from people whitelisting star, obviously. One major company whitelisted all of their subdomains. And that was a problem because one of their subdomains had persistent cross-site scripting on it, so I could direct users' reset tokens to that subdomain, wait until they ran into the cross-site scripting payload, and then use document.history to grab the token from the browser's history. Also, obviously, the host header is user input. It should be treated as such, and caches should always pay attention to it, and reject requests that have multiple host headers. A naive way to deal with this technique is to use relative links. Relative links can backfire, as Gareth Hayes reported fairly recently. In particular, path relative links rely on the web browser working out where the current page is located on the server, like what the path is. And in some cases, we can trick the web browser about what the current path is, such as on JSP and PHP applications. We can generally put arbitrary content that the browser will think is part of the path that is not, such as there. That semicolon signals the end of the location from the server's perspective, but not from the browser's. So if you load that page with that kind of style sheet include on it, then the browser will end up loading the current page as a style sheet. And this is a problem because style sheet parsing is extremely lax, and style sheets can contain JavaScript and Internet Explorer and do various other bad things in other browsers. So the web browser will load the current page as a style sheet and then walk through it until it encounters any CSS and then execute it. So I've just covered three of these requirements. You need the right kind of server, and you need some kind of input onto the page to put your CSS on that page, and you need the path relative include. The first two of these are really tedious to look for manually, especially because a web application will tend to have a doc type on, say, every page apart from one where they forgot to put it there. So ActiveScan++ passively looks at all of your responses and flags pages that are missing those two, that fulfill those two requirements, and lets the user deal with the rest. I can't demo that issue, unfortunately, because although I found it in some fairly major software, it hasn't been patched yet. So, finally, as developing part of ActiveScan++, I've been looking at how scanners currently work, how I can improve them. That's a classic directory traversal vulnerability. The application can be tricked into interpreting arbitrary files on the local file system as PHP, or reading them in and printing them out. And vulnerability scanners look for this vulnerability by using a payload, something like that. That's extremely common. I've seen that exact payload being used in multiple different ways. Nulls don't work. Yeah, yeah, exactly. This payload has many, many problems. If null bytes don't terminate, as in modern PHP, then this technique won't work. If the red file isn't displayed back, it won't work. If there's an input length limit, it won't work. If it's Windows, it won't work. And scanners can try to deal with this by adding more and more payloads, but the payoff of each payload drops when they're that specific. And they will always miss things that are vulnerable to this technique. And what I've been looking at is breaking the techniques down to the absolute minimum required to establish that there's something suspicious going on that's worth investigating. For example, if the 573 input gives you a receipt for something you've bought, /573 gives you the same receipt, and /dot breaks the application or gives you a different receipt or a different response in any meaningful way, then we can tell that input is being used in a path, almost for certain, I think, and that it's worth manually testing heavily for that kind of exploit. And just as with manual testing, we can use similar sets of payloads for other vulnerabilities, any kind of server-side issue where you can inject syntax like that. The keywords there were identifying significantly different responses, because HTTP responses are well known to be extremely variable. They have all kinds of content that just changes every single time. They often reflect input, which is fairly easy to handle, but they will also transform the input in unknown ways by encoding it and such like, which is harder to recognize. They will put timestamps in, and they will just put random input in. And some scanners try to handle this by fingerprinting the document structure. They effectively remove everything that isn't a HTML tag and say, that's what the page looks like. If they start putting new tags in or changing the order of tags, then something major has changed. And it's reasonable, it does the job, but it will miss things. The approach that I've taken is detecting these fuzzy points within the page so that when they change, we can go, I was expecting that to change. I can disregard that. In other words, I'm generating a regular expression to match what a page looks like when it gets a standard input. And by fetching a sample of inputs, we can do this. So this shows the result from a page from a real practice application. And we can see over here where user input has been reflected, and the application has it hasn't recognized that as user input, but it's seen that it's changing and just filtered it out. So whatever appears there, it won't think that that's an interesting result. It's the same with the PHP session ID up in the top. So when this technique works, it gets very interesting results. It isn't public yet because applications still break it. It has serious performance issues associated with generating regular expressions for very long responses. but it has found very interesting issues. Mostly issues that I couldn't exploit personally, but I would love to view the source code that generated those kinds of things. And I think they may have been exploitable given that source code. And it finds issues in such a different way that it finds different things from other scanners, which is very interesting. I'm tempted to say that it's a little bit like an nmap for websites, right? It just pokes at the website and tries to work out where the interesting responses are, like how different inputs are being handled, and should show you which ones are interesting and worth investigating further. The obvious next step would be to tie payloads to specific results. So if we see that that directory traversal case, try a large set of payloads related to that and see if we can refine it and get a better idea about what's going on. Okay. Yeah. So the take-home is that proxy plugin scanning unifies manual and automated testing in a really nice way. It just lets you stand on the shoulders of the manual tester. Existing solutions are far from perfect and can be easily improved on, and writing these plugins is almost painless, which may be a mixed blessing in the quality of the plugins that come out. I can't really talk after my demo, but it normally works. Yeah. Okay. Any questions? Yeah?
Very interesting. Thank you for the great talk. I discovered a similar thing, and where we replaced a host header. And I did some research on it, and I think a host header, which shouldn't belong to the to any virtual host on, for example, Apache, should just give a 400 or something like that.
No. On
Well, according to the HTTP 1.1 RFC, it should.
yeah.
And in some system it does. In other system it doesn't do very well. For example, I saw that you were using Fedora system.
Yeah. Yeah. I've.
Ubuntu and server Linux, I didn't see that. And you cannot manipulate a host header, so you get a 400.
Even if you send an absolute URI.
Yeah.
Okay. I have found this in a wide range of externally hosted sites, so it's certainly a pretty common setup. And yeah, what I found is that Apache has a default virtual host, and if it and typically if it gets a host header that it doesn't recognize, it hands that request to the default virtual host.
Okay. Yeah, it could be that's a default setup of different systems.
Yeah.
Or systems different. Okay. Thank you.
Okay. Any other questions? Sure. Thank you.
Hello, I'm Matt Tesaro. I'm going to be talking about Barbican, protecting your secrets at scale. If I say Cloud Keeps a couple times, that was sort of our internal name before it got this official name. So I'm going to warn you, I may use both terms. I may say Cloud Keep, I may say Barbican. Apologize if I mess them up. But then we started calling it Cloud Keep, and then we renamed it Barbican. So my brain gets confused. But this is about protecting your secrets at scale. A quick little background about me. I'm Matt Tesaro. I'm a former OWASP board member. I started the Live CD project back in 2008. It's kind of morphed into OWASP WTE, which is a bunch of Debian packages of AppSec tools. I've been at Rackspace since October of 2011. I work for the Product Security Group, which is our internal AppSec group that works actually in the product dev organization. I'm testing our products, and I'm sort of trying to hack the rack, right? And my other cohort, who is not here, who did actually a lot of the work. He's the one running the team, actually, that is creating this product, is Jarrett Rame. He's been a developer. He worked for the Denim Group for a while as a consultant. He's been at Rackspace for 4 or 5 years now. He's the one who actually runs, this is where I have to say this very carefully. I do product security for Rack. He creates security products for Rack. So like he creates the stuff that we sell to customers, and I try to break the stuff that we sell to customers, okay? But I've known Jarrett for a number of years. We're good friends. And he and I, this kind of evolved out of many lunch conversations and drawings on napkins, and this is a problem, and how do I address it? This really actually came out of a problem of, as a security professional, I hate going to dev teams and saying, you're doing this wrong. And when they say, okay, what do? I say, I don't know, but you're doing it wrong. Right? So this was an attempt to provide, at least a portion of this was an attempt to provide the right thing advice to devs when I would find something that was being done wrong. Because I think that's kind of a fail from a security, app security point of view, right? If I'm an app security person, I say, best practice says you shouldn't do this, and they say, great, what do I do? And you go, I don't know, you're just kind of screwed. Like, that's not a good answer. So hopefully this provides a good answer. Oh, the other background on this is more Jarrett's slide, is that we surveyed our customers and said, look, like security, that's a broad term that sort of has not a lot of meaning. Specifically, what are the things you care about? And so we broke it into these buckets of data protection, endpoint network protection, identity access control, AppSec, vulnerability incident management, and configuration and patch management. And which ones were the ones you really care about? And data protection was by far, in a way, the most popular answer, right? And if you have data protections, you probably have key management issues. That's crypto, right, doesn't solve problems, it just moves them elsewhere, right? So that was a big one. And then the other one that surprised me, quite honestly, is application security was the second biggest answer, which I did not expect, but those are some interesting numbers. So the other thing behind this was, at Rackspace we use OpenStack, right? That's what powers our cloud. And we have a lot of, obviously, OpenStack developers in the organization. And prior to one of the OpenStack summits, I was doing some reading of, when they're proposing new features to OpenStack, they make blueprints, right, that say, I want to do this with this service, and this is how I think it should be implemented. And it's kind of a somewhat of a diagram and a little bit of code usually about a concept of how it should work. And so we started looking through, before one of the OpenStack conferences last year, at all these various systems, and all of them wanted to start doing crypto of some sort. And we looked at Swift, for example, and you look at the diagram, and here's the Swift API nodes, and here's the data storage layer, and et cetera, et cetera. And then in the corner, there's this little thing that said key manager, right? And you go and look at the code for it, and it was a bunch of empty Python methods. Like, so there was a key manager, but there wasn't really anything there. And then we keep seeing those in different parts of OpenStack. So if this had sort of gone on, there would have been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different key managers in OpenStack, which is kind of ridiculous, right? This is a crucial bit of software that you need to really do right. And if it had gone kind of the way it was going, there would have been 10 of these things. And so Rackspace said, you know what, we're just going to make our own and make it as part of OpenStack. And so this was where Barbican came from. And then the other one, and this was the paper napkin discussion of like no good answer for devs. Right, if you have an app, if you're doing custom dev, inevitably you have some sort of scary data in a config file, right? Be it a database credentials, a API key, something, right? And particularly in the Linux world, there's not a really good answer as what you should do with that, right? What do? Well, you put it in Etsy and you own it by root, right? File permissions, that's not such a great answer, right? How do we make this better? And so one of the things we wanted to solve for is how can we give developers a method to do something a little more robust with managing the secret data that you have, usually config files or API keys or something, right? A little more stronger. And we're also working on SSL keys as well. And I'll talk about that near the end. So, Barbican Key Management as a Service, there are sort of 3 separate ways for you to deploy this, or 3 interaction models, let's say, depending on your risk level and your convenience level, quite honestly. So we have transparent encryption, federated keys, and on-premise are 3 different ways you can interact with Barbican, going from kind of least secure to more secure, and I'll talk through what those look like. So transparent encryption is basically we have your key and your data, and we encrypt it, right? So you as a user, you just save something into Swift, which is our object store, and it just gets encrypted, right? Obviously, this is the least secure because we have your key and we have your data, but if you just need a tick box for compliance or something that your data is encrypted, this will get you there. And certainly it's the simplest method for you to manage this process, right? Because it's all just API calls. And then for more risk-adverse groups, we have this idea of federated keys where you would talk to the consuming service like Swift, the object store, and say, I want you to encrypt my data that's going into Swift. It would reach out to Barbican, and Barbican would know this is a federated user. And there's 2 different interaction models. This would either reach out to your on-premise Barbican install, get the key and push it back here, or tell the consuming service, Swift, you need to talk to that Barbican instance to get the key. So this way you have the key, but we have your data. And then the third one is on-prem, right? You just run it all yourself, and we have nothing, right? So those are your sort of 3 deployment options. So what does this guy look like? So at Rackspace, our deployment is a load balancer with some number of API nodes behind it. We have a queue from which workers read off of. We have a database to sort of store metadata. We have HSMs deployed, and I'll speak a little bit more about that in a minute. HSM is a hardware security module. It's a specifically hardened piece of gear to hold crypto keys. We use Ansible and Chef, and we have some metric services to keep track of everything that's going on. But this is sort of the standard large-scale horizontally scalable deployment if you want to get an idea of what it would look like. And then key storage. So we found out when we were starting to create the Barbican service that a lot of the HSMs are really not made for multi-tenant. In fact, they're not entirely at all made for multi-tenant. And there's certain limitations on number of keys. And we don't want to store 100 keys. We want to store 100,000 keys. And so what we ended up doing was creating a key encryption key that stays and never leaves the HSM. And that key is used to encrypt any keys owned by the tenant. So there's per tenant, oh, and I should explain, tenant in OpenStack speak is customer. So per customer encryption keys, right? So all of your keys for that particular customer are encrypted with this one key encryption key. So you give us secret data, we encrypt it, and then store it in the data store. And the HSM holds that key encryption key. So it's a way we can scale out HSMs, because we originally thought we'd just store everything in the HSM, but they just won't handle the throughput. And they're also not cheap devices by any stretch. So we didn't want to have to buy 100 of them, right? Kind of makes it a cost-ineffective service to offer. And then the agent. So this was a lot of my discussion with Jarrett Rame about, well, this is great, and like if you're writing brand new apps, you just talk to our API, right? Hey, I need my encryption key, and it will hand it to you, right? Cool, but what if you have legacy apps? Like, well, we all have apps that are in production running right now. Like, what do you do? And so we ended up with this idea of using a Fuse file system. And a Fuse file system, this is all for Linux, by the way. A Fuse file system under Linux is a file, some code that sits between the kernel's system calls and user space calls to create a file system under Linux. So I can create what looks like and smells like and acts like a file system, but it's really my code running. We would use that to create a pseudo file system that was only in memory, and then wrap policies around that. So now I can do things like know who, what, and when that file gets read, and say who can read it and who can't read it, and what's odd about it. And I'll show in my demo, I'll show this in process, where we have a policy that says you can only read this once, and you can't read it twice, right? So therefore, you can't read it twice. And actually keep someone, like the traditional attack scenario is, I get access to a box, or maybe I have directory traversal. The app can read the key. I can read the key, right? So I read that config file. I get all the goodies. I write up a nice pen test report, and I go home. Right? Well, under this case, if you only let it read once, that app will start. It'll pull that stuff into memory. And then anybody else who touches that config, I can now notice. Because right now, as an app, someone running a whole bunch of apps, you have no idea who's looking and reading at that, or interacting with that key or that secret material, right? Keystone integrated, this is just the, this is more for OpenStack. OpenStack's identity manager is called Keystone. So this is integrated with Keystone. And one of the nice things is that the agent that's running that Fuse file system can then talk back to the API and give you this out-of-band communication. Hey, this process read this file at this time, which you don't have right now, which is, I think, kind of cool. An example policy. So what do these policies look like? So it's a policy. Here's this UUID, just a uniquely way to identify this specific policy. Time available after reboot. This is an idea if you can say, if it's more than 10 minutes after reboot, nothing should read it. I don't care if it's never been read, right? So you can have these various policies. The keys stanza, this is the secret. So this is 48.2, I think, characters of random data. You can say what group, and if you drop down a little bit, what owner can read that key. Here's a UUID, just uniquely identifying the secret. You can attach expiration times, which is nice. Right now, you can actually have an API that you can query to find out when your keys are expiring soon, right? Which for SSL, like, never happens, which is why we're using this for SSL at rack. But you could also do this for just key rotation, right? For compliance reasons. I must rotate that key every 90 days. Now you have sort of a countdown timer tagged with that key. Cacheable means, can you cache this? Can the agent cache this in memory, or does it have to make a request back to the API for every time? So if you're really concerned about someone getting access to that box, you can have the API, when I try to read that file, actually make an API call out, pull the key and hand it off, and then drop it out of memory. So it's never even in memory for very long on the server. The MIME type is just a way to understand what might use this data, because to Barbican, it's just an arbitrary bunch of text, right? We don't pretend to know if this is an SSL cert or if it's just a password or whatever. And then the file name, this is the file name that will be mounted in the directory on the server under Fuse. Now, tenant ID is just who owns it. Max key access is 1, so I can only look at it one time. If I look at it twice, bad stuff happens. The directory under which to mount this is etc keys, and just a name for this policy, example inc, whatever you want to name it, right? Just a label so that you have a human readable, not a UUID, to deal with when you're talking about these policies. And then events. So the agent has this concept of logging events, and you have multiple targets for events. You can write to a file, just traditional log files. You can write to syslog. And in the demonstration I'm going to show you today, we log back to the API. So this is a way to track boxes sort of on a separate channel and off box, almost like shipping off your log files for access to anything that is confidential or secret or somehow sensitive. The nice thing is that you can now get a hint that something's going on with the compromised server, right? I get access to a server, the first thing I want to do is look for the goodies. And that activity of looking for the goodies is going to cause these events to be propagated to the API or your syslog server or what have you. And now I have a chance to notice a compromise going on at the time it's happening, right? Depending on your policy, you can have what's called a panic. And when the agent panics, when you violate policy, depending on settings, the way I have the proof of concept I'll show you is I drop everything from memory and I basically shoot myself in the head. Well, not me, but the agent, all right? And so it just drops everything and goes away and nothing's on disk, after sending a message to the mothership saying bad things have happened. So in that case, if you have a bunch of API nodes serving a particular part of your infrastructure, node 7 panics, you take it out of the load balancer rotation, do forensics or whatever you need to see what happened, but pop up another one and off you go. Right? And it's a quick way to be able to react to compromises across a horizontally scaled application. I think I said everything. Yes. Oh, and going off-site obviously helps you with things like PCI, or off the box helps you with PCI and other compliance regimes. Yes. Yes. Cool. Come on. Oh, demo time. Okay. Let me show you. So full disclosure, right? I have, I got to move these over to the other window. So here's one VM running. Just a standard Linux install. Here's a, hey you. Here's the second VM running, standard Linux install. This one is Postern, which is the agent. And this one is Barbican, which is the UI and API. And then I need to drag this guy. Wow, that's going to be small. OK. Wow. Let's see if I can make this work. In fact, hold on. I'm going to mirror my screens, because I don't want to look over my head. Much better. OK. Yay. I don't have to crane my neck. So we have Barbican here. This is where the API is running in the web interface. I'll show you. Postern here, which is the agent running on a server, which would be where your app would be. And this is me sort of simulating interacting with that policy, or the key file, and showing you what happens if you violate policy. Where did Firefox go? There's Firefox. OK, cool. Oh, wrong one. Let me fire up Barbican. And there we go. So I'm going to log in. This is just a quick and dirty web interface, so I can have nice looking demos, because like showing curl is not that exciting. Come on, remember. OK. So we have a tenant, which is in Rackspace or OpenStack speak as a customer, right, which is just identified by this unique ID. We have a key, like I mentioned earlier. Right, so this key is bound by this policy. Here's the unique ID for the key. Here's the file name secrets. Here's the application type. It's a encryption key for AES. Here's our expiration date, 10/28 of 2014. Here's the secret, those 40 some odd characters of random text. It'll be owned by root. It'll be group owned by root. And cacheable means that I can store it in memory on the agent in the file system, the Fuse file system. And then if you look at policy, this is much like the example I showed you earlier. For this particular tenant or customer, here's a uniquely identifying, or a unique ID for this policy. The name of it is the example policy. We're going to mount it under etc keys. It'll have one max access, and it can only be accessed 10 minutes after boot. All right? And if you notice, we have no events and no agents, right? So we need to fire up an agent and have it pair with this, this API. So I'm going to go back to Postern and fire up the agent. All right, so it says, like, is this readable? Yes. OK. So info log sent to API and init complete. So I've mounted the Fuse file system. And there's a particular kernel module in the Linux kernel that lets me sort of intercept file system calls. And instead of going directly to the kernel, they go to my code. And then my code can either pass them back down to the kernel or do something. And so this is how I fake a file system under Linux. And I will show you that in half a second. But first, if we go back to the events, you'll now notice for this tenant and this key and this agent ID, at this time, I now have policy being enforced for etc key secrets on this host. Right, so now you know that the agent is up, it's paired. Actually, here's the pairing of the agent, right? So the agent is up and paired. It's running on this particular host, Postern demo. It's running this particular OS version, and the agent, like just a version for the agent, right? And so now we know that the agent is up and running and has a Fuse file system mounted for this particular, it would be like a config file for an app. And if we go back to here, and so I'm root and I'm in my home directory, I'm going to ls/lah/etc keys, and it looks like a file system, right? So let's go ahead and cat/etc keys. Secrets, and there's that 42 character secret, right? Now if we go back here, you'll notice that there's an info log. I did exceed my uptime restriction because I fired these VMs up a long time ago. There's an info log sent to the API, and if we go back to the web interface now and we refresh this, you'll notice that, hey, at this time and date, Etsy Keys Secrets was, access to Etsy Keys Secrets was allowed by policy on that poster and demo host. So now we're actually getting visibility into something reading this file that has scary secret data in it. And if we go back and run this again, nothing. And let's go look at that directory, like what happened. There's not even a directory anymore. Now if we go back and look at my other shell on Postern, I've panicked, right? There was a policy violation. I tried to read it twice, which is disallowed. And if we go back to the UI, you can see now that we've had a policy violation. I've panicked, and I've cleared out of memory, and there's now no secrets to be read. So the idea with this is it allows you to actually have visibility into access to these particular config files that are scary. Now, obviously, if you're writing a new app, I would directly call their API. That makes a hell of a lot more sense. But there's also, we thought there's tons and tons of legacy existing code. Why not provide a means to be able to have visibility into access and actually do restrictions upon access to those various files that you inevitably have to have? Because crypto, right, there's always a key that you have to do something with. And you can put the key in another key and encrypt it, but you just have this turtles all the way down thing. And so hopefully, this will allow you to get out of that race, or at least get some visibility into it. Let me go back here. Ugh. Really? Whatever. Okay. So what's next for Barbican? And I should mention well, one thing. Barbican started out as a Rackspace project. It was always going to be an OpenStack project, and it's gone through the incubator process that was for OpenStack. So it's now an official part of OpenStack. You can download Havana, which was the release before Icehouse. Or you can download Icehouse too. And you will get the latest Barbican code. Why am I getting that silly resolution thing? That's really annoying. There we go. Okay. Sorry, that was annoying me. So it's now official part of OpenStack. If you want to download and get this, the only things you need to run it is Barbican and Keystone, which is the identity service for OpenStack. And there's plugins for Keystone to plug it into AD or various LDAP stores if you want to sort of tie it into your existing infrastructure. The current state of what they're working on next for Icehouse, which is the next OpenStack release, is keymip support, which is, I'll be honest, kind of funny because everybody asks for keymip support, and then you ask them, do you use keymip? And they say no. Keymip is the key management interaction protocol or something like that. I can't remember, but it's a standard for doing key management between two hosts. And I guess it's a good standard. It's an OASIS thing, but like nobody has actually implemented it. So one of the HSM vendors, SafeNet, is actually writing a Python keymip library. And if and when that happens, we'll integrate that into Barbican, or if not, we may just end up writing our own because we get the question all the time, but it's sort of like a chicken egg thing. Like people want it, but nobody's using it. So I'm not quite sure the value of it there. SSL and TSS, this is another great thing that I think is really going to help with Barbican. Now you can manage all of your certs, and we're integrating with either internal or external certificate authorities to where you can now get, issue, and manage certs all through Barbican, which if you have an HSM now is backed by an HSM, and you have things like countdown timers, and you can write web interfaces talking to REST that'll let you know this cert is expiring in so many days, right? It's sort of a nice centralized managed place to handle all those SSL certs. We have federation going, and we're working on the additional federation methods, like the method I talked about where you talk to, say, Swift or the service. It talks to the Rackspace's Barbican, and then it talks out. We've got the service, Rackspace's Barbican to a third party's Barbican, and then back out avoiding Barbican, but both models we haven't got quite worked out yet, so the second of the two models is not done. And well, just is really more OpenStack directed, but we're working with the various and sundry OpenStack teams that want encryption to integrate with Barbican so that there is the key manager for OpenStack and not N key managers for OpenStack, because that was a bit of a problem. And if you want to play with it now, you can. We have a Python Barbican client. It's open source and on GitHub. Actually, all of this stuff is open source and on GitHub. They've got very good documentation and their source code. There's an integration environment if you want to play with this and talk to a Barbican API. That's fine. It's obviously for dev only. I wouldn't put anything you give a rat's A about because this is a dev environment. Do not put real secrets in this, right? This is where we make sure the clients work. This is not where you put real stuff. And there's also a command line client called Keep, staying with the castle motif, that allows you to do client operations so you don't have to type these big long REST strings or big ugly curl. Wow, and that's it. That was quicker than I thought it was going to be. So the teams that's on pound OpenStack CloudKeep on Freenode. GitHub/CloudKeep is where all the code is, and Barbican at list.google.org is where all the devs sit and answer questions. And pull request accepted gladly if this is something of use. Oh, and I should mention, if you look at the code that I demoed, you will notice it was Barbican-POC. It's proof of concept. So the policy is not implemented in the official OpenStack instance yet. That's being worked on currently. We basically wanted to prove out it worked before we actually did the whole get it into OpenStack thing. So this code should land. I'm working on a Go version of the agent now, and hopefully this code should land by Icehouse, which is this fall, I think September, maybe October. So this should be for reals available in September, October. Any questions? Going once, going twice? Sold. Well, thank you very much.
we'll probably start because Richard Stallman took our show. So. Okay, let's go.
Okay. Hello, can you hear me? Yeah, okay. My name is Sławomir Jasek, and here is my colleague Jakub Kałużny. We are both pen testers from Securing, from Poland. That's sorry. That's from yesterday's dinner with our with our celebrity woman in AppSec. Well, she didn't authorize this picture, but I still count on the promise that she will cheerlead our presentation. So we provided her with the tools to that. So please encourage her. So. Besides partying, we do security assessments of various software components and software applications, networks, systems, and so on. Among them, many proprietary solutions. That's obviously often in real-world situations. That's okay. Obviously, apparently, we are not in our best condition today after yesterday's party. So feel free to help us to find and spot some vulnerabilities in systems we will show you. Okay.
Okay, I'll show you our agenda for today. What the hell? Okay, so our agenda for today is showing you some real-world case study proprietary network protocols from industrial proprietary systems where they use binary protocols, binary network protocols. So here you've got the list. We've got home automation, pool printing solutions, remote desktop, and the biggest one, Forex trading software. And these are the real vulnerabilities we found during our assessments. And apart from showing the practical part, we'd like also to talk something about the theory of testing proprietary network protocols, and we'd like to show you our approach to testing proprietary network protocols. So we will show you the cheat sheet, and we'll tell you how to hack it. So proprietary network protocols. Let's get some interaction. How many of you are pen testers? Any? 1, 2, 3, okay, 4? Great. So have you encountered a proprietary network or a binary network protocol during your tests? Or only web apps? Anyone? So, okay. Okay, so that's quite good. So if you didn't, you will, because proprietary network protocols are very common. And there is a problem with testing proprietary network protocols, as you don't got tools. You cannot use some local proxy for HTTP or something like that. You've got like a raw data on the cable, and you have to think what is it and analyze it. So what are the ways to test proprietary network protocols? You can decompile the client if you've got, for example, a FIC client in Java or something like that. You can decompile it and then analyze what the software does, and then write your own client, for example. You can search for some tools. There are some tools that help testing proprietary network protocols. For example, SCAPI for intercepting the traffic and so on. But what we do mostly, and what worked in our cases, was actually watching the raw packets on the cable, analyzing them just with like our minds, and writing actually on clients or replay scripts for these protocols, only tampering some data. So let's try to do this. The first example is Slavek's.
Okay, so for a teaser, our first example, it's quite simple. There's a protocol to remotely control your home automation system. You get a small device, appliance from the vendor. You connect it to the home automation network, and on the other end to the local network. you configure your router for port forwarding to direct access from the internet to this appliance. Yeah, that's strange. But that's how it works. And there's a proprietary network protocol which connects directly to this appliance. And the connections is secured by the password. So let's have a look at a few packets, how it looks. That's what the client sends. And that's the answer of the server. Well, then the client sends something like that, and server sends, again, something similar. Can you think of something particularly interesting there? Do you have any idea how to attack this protocol? Any ideas? Yeah?
My rough idea is that I see lots of duplication in the response. My rough idea is that since I see so much duplication in the response, that there might be some encryption using padding. So maybe a very short encryption key for a longer message. That's my rough guess.
Well, the truth is much simpler because, in fact, we could use in our testing environment, we could change some things, and for example, change the password. We can configure it, and look how the packets behave. For example, this is how it looks with first password. This is how it looks with the second password, and with the third password. Well, obviously, you can see where the password is. So, of course, it's some kind of obfuscation. So it turned out that, in fact, the client sends just internal command, which is directly transferred to the home automation network, and it's followed by MD5 of the first bytes of the password. And then the server responds in a clear text with the status of this whole appliance, I mean, sensors, settings, and so on. So obviously, this is vulnerable, of course, for sniffing, because we can see the internal status of this appliance. We can do man in the middle, of course. We can connect directly to the appliance. We don't need to know the clear text password because it's just enough to know the hash. So the recommendation was SSL to encrypt the traffic, and vendor added this SSL support. It took a while because they had to deploy it on all of these appliances at the clients. Well, they did, in fact, it turned out that they did something like that. So I guess you all see what's the problem. Yes, exactly. They created empty trust manager, which accepted all the certificates. Well, it's a very common problem in Android applications because the client was an Android application. But of course, that didn't help to remove all the problems with that. We can still do man in the middle. So they have to patch it at this moment right now. An interesting thing was a side effect because their business model was to provide an expensive appliance and, of course, free applications on the Google Play Store and iOS. So it turned out that after decompiling this protocol, I could just use these 5 bytes and send it to the internal home automation network, cut off the password because it's not necessary for me. So I can simulate this appliance with this single line of code. And of course, I had to alter it a little bit for the SSL support and create a self-signed certificate. And it runs perfectly well on my Raspberry Pi. So that's some kind of interesting case. So that's it for the first guys. Please show it.
Okay.
Oh, you have my.
Okay, and now let's switch to pull printing. So I've been recently doing big research on pull printing solutions. First, I'll try to explain you what is a pull printing solution. Like in normal situation, you would print files directly to the printer. But you know, in big offices, in banks, in financial corporations, you use pull printing solution, which works like that. The user sends the file to the server. It's held in a print queue. Then he walks to the printer, because there are many printers in the building. He authenticates there, for example, with a card swipe or just by typing the password. Then the printer sends some request to the server to collect the print job from the print queue. It's released by the server. The files go this way. And maybe later there is some communication to send information about charging for this action. So we've been testing this pull printing solution in one of the banks, and we found so many vulnerabilities in there that we thought maybe we can just buy a printer and hack more vendors, because there are many vendors who produce this pull printing solution, and it worked. Why pull printing solutions are so interesting? Because, well, first of all, they're widely used. They're used in banks, as I said, in financial institutions, big corporations, because they all handle a lot of confidential data. And the data is this is the target for our attacks. And it's getting very, very popular. For example, in Poland, the financial government institution, which publishes some references for banks, recommended to banks that all the files in the bank, all the printed files, should be encrypted on the way between the server and the printer. So now banks are deploying pull printing solutions. So yeah, let's get some interaction. So what would you say? Let's make a quick threat modeling on pull printing solution. What would you say? What is the Q risk for a pull printing solution? Anybody? Yeah, just shout it.
This is not so much on getting the files, but we managed to, at the university, hack the queues. So you could actually we wish somebody happy birthday by hacking their queue with all the file names.
Yeah, good one.
They just clogged up their queue. They had like 50 different items. Because the actual queues were unsecure.
Okay.
Anyone could write to somebody else's queue.
Good.
The obvious issue in the bank would be for someone printing a document that's not meant for them.
Yeah, exactly. So getting to the print queue of director, let's say, and print some contracts or payrolls. Anybody else? Okay, so we're talking about, first of all, sniffing the documents on the line between the server and the printer, getting to the other print queues, tampering the accountability. So, for example, printing for free, for example, at the university, and getting users' data, printing history, and some more users' data. So the attack vectors for these solutions are man-in-the-middle attack on the line between the server and the printer, and we'll also access to the other print queues there. We'll try authorization bypass near the printer and stealing users' data on the server interfaces. And if there are any, for example, web interfaces, we'll try to find some vulnerabilities there. So I would like to show you first binary protocol, because mostly the pull printing solutions are deployed as embedded software installed to a printer. These are like big printers, 50 kilo. We bought like a 50 or 60 kilo Lexmark X654DE, and they've got everything, hard disks, USB port, Ethernet ports, and so on, and embedded system, and the possibility to install embedded software there. So the first case study was pull printing, which is mainly used on universities. And they write on their website that with its root in education and the full understanding that college kids like to hack, their development process continually focus on security. And we'll try to challenge that. That sounds like a challenge for me. If I see something like that, I'll just take out my laptop. And they also say that secure print release can integrate card swipe authentication at devices, and it ensures that the jobs are only printed when the collecting user is present. And yeah, we love to see the vendor claims and to verify those claims. So the first binary protocol was encrypted, but for this case, I'll just take out the encryption level and show you what were the packets. So first, the server sent some hello message. The printer responded with the username. The server sent a token. The printer responded with a hash of this password plus token. The server verifies if the password is OK. Then the printer sends the actual communicate to release the print queue, or for example, I copied 100 pages, charge me for it. And then the server says, OK. So what would you say? Where to inject, where to tamper this protocol to get some vulnerabilities?
I would try to call the methods out of order. So try to release my print queue command before giving it the password and see what happens.
OK. No, the authentication was needed to do these communicates. It is one TCP connection. It's not like HTTP different requests. It's just in one TCP connection. Anybody? Okay, so like mostly people say that they would inject, for example, try to break this hash and try to authenticate as another user. We tried to do this, but actually after a few days spent on this, we found that the hash algorithm is OK. The token is perfectly random. It's one-time token, and everything here is OK until this moment, because these communicates, you are actually quite right. These are the key communicates in this communication. So I'll show you how does it look on the wire. So on the wire, it was a binary protocol with some clear text, let's say. First, the server, well, the blue ones are from the server. So the server responded if the authentication was OK, and sent some permissions, user permissions. For example, if he can copy in color, or for example, something like this. Of course, later it turned out that there are also vulnerabilities there. But we tried to tamper the communicate from the printer to release the print queue. So the guest XYZ was the username of which was authenticated. And of course, yeah, what we tried to change it to another user, let's say guest ABC. And it worked. So already after authentication, we authenticated as guest XYZ, and then we just get the print queue of guest ABC because there was no authorization check later. So actually, this was not a communicate release my print queue, but it was release print queue for user I typed, and not just copied 100 pages, but charge user I typed for copying 100 pages. So the consequences of this attack were actually, it fully broke all key risks for pull printing solution. We were able to sniff, print other print queues, tamper the accountability, and still uses data. But I say that this was a very positive example. This was our third or fourth case of pull printing solution, and we tried to reach the vendor before the penetration test, and we just asked, "Hi, we would like to hack you. Do you want to give us the software?" And they gave us support service and knowledge base and all versions of the software. After sending them the report, they responded in few hours and patched, and actually they deployed the patch and gave it to their clients because they had many clients in few days. So that's the vendor that we would like to cooperate with. They really looked happy to be pen tested, which mostly in other 5 cases of pull printing solution didn't work. Okay, so the next case study is Slavex.
Okay, so next example is remote desktop protocol. We would say it's some kind of X Windows with added layers of encryption, compression, access control, and so on. It's used mainly for mainframe access, for example, in banks or financial institutions. to graphically display some kind of programs, for example, for foreign exchange or something like that. The vendor states that there's more than 100,000 users around the world, and that they are FIPS 140 certificated. So they are supposed to be, the protocol is supposed to be secure. So let's have a look at it. The first packet sent by the client looks like this. That's the second packet responded the response of the server. And what follows is basically an SSL. So, of course, we can hack the SSL. We'll get to it later, because it was vulnerable too. But any ideas for what can we do about the first two packets? Excuse me?
What happens with you try other values?
Yes, of course. We have tried other values over there. But it turned out that the server didn't took us for serious. I mean, the server didn't respond for anything else than 0101. But if you tried other value as a response from the server to the client, it turned out that the client dropped the SSL and connected in a clear text. So it turned out that this is the protocol version, and the previous version of the protocol did not support SSL. So it's some kind of backwards compatibility of the client, which after receiving this response from the server, connected through the clear text. So of course, a malicious user could do man in the middle of this first two packets, send to the client this modified answer from the server in order to get clear text, almost clear text credentials. So here we have user login and encoded password. So of course, this encoded password is very interesting for us too. So we find out that after entering a longer password, it's the encoded version is also longer. So it's some kind of obfuscation or something like that. So we took, for example, this password, which is encoded in ASCII hex like that, and the hashed version of it looked like that. So it was the same length. Any ideas? What can we do about it? Yes, we can change one letter, and there also changes one letter. Okay. So
a substitution cipher or even a one-time add?
Well, could it be the most popular encryption? I mean, crappy encryption method. I mean, XOR. Well, let's have a look. We can XOR these two values. I mean, this is clear text password. This is encoded one. We get something like that, which after decoding this ASCII hex turned out to be a company name which created this wonderful software, which was in fact the key that encrypted this password. So of course we can get a clear text of this password when we know the key. Let's get back to the SSL. In default configuration, the server didn't have any certificates configured. So it couldn't do any of this DSS, RSA, or something like that. He could offer to the client only anonymous cipher suite. So obviously this is vulnerable to the man-in-the-middle attack. And that's the configuration we saw in the real world. But of course it's vulnerable, as you can see. But let's assume that someone properly configured this certificates on the server, and the communication looks like this. The client says, "Client, hello." Server responds with proper certificate. During the first connection, client pop-ups a question: do you accept the certificate? You can check, for example, MD5 of a fingerprint. That during the following connections, the client can verify if the certificate is still the same, and if there's some kind of man-in-the-middle attack, it can send an alert. So, any ideas? What can we do about this protocol? How can we hack it? Excuse me? Previous certificate.
So it doesn't seem to revalidate the certificate every single time.
Yes, it does valid. Well, let's assume that this configuration was during the first connection. The certificate was configured in secret, proper network, and nobody could tamper this first communications. And on the following connections, it checks if the certificate stored during the first connection is the same. So you can't do this kind of the man-in-the-middle attack. But how about, do you remember this? What if we changed the server answer so that it answers something like that? We would expect that the client would drop this connection because the client has the certificate already stored. But unfortunately, client does accept this connection, forgets that it has already configured certificate, and happily connects to the server. So we can do, by downgrading this protocol, we could do man-in-the-middle and send to the client the anonymous cipher suit. The communication with this vendor didn't go very well. So after initially setting a secure communication channel, which wasn't very obvious for them, it didn't go very well. I mean, we sent a few emails that if they need any help, do they plan to solve this in a timeline? We would like to help them. Maybe we need some help. Well, we felt a little bit ignored. So after a few months, we decided to go full disclosure, our favorite. Unfortunately, the vendor didn't react to that. I'm not sure how it affects the FIPS 140 certification, but it's still not repaired. A few weeks later, they closed the full disclosure. I guess that's just a coincidence. Let's go to another example.
Yeah, okay. Okay, let's go back to the full printing. More cool examples of full printing solutions. Well, actually, I didn't know how much cool was the full printing solutions topic, but until it got accepted into every conference I sent the paper for. So the second vendor states on his website that it is a modern printing solution that safeguards document confidentiality and unauthorized access to print, scan, copy, and email functions. And it provides airtight security. So yeah, we love it. When someone says airtight security, again, I take out my laptop. So some more corporate blabbling from the vendor. He states that the documents are delivered only into the right hands. The information is kept confidential. There is no risk. Well, everything is safe anytime and anywhere, and the workflow is kept secure. So we would like to challenge these claims and and check the binary protocol. So on the first look on the communication, we saw that it is TCP using 2 connections on 2 ports. There was no clear text. There was some encryption inside. But it seemed to follow some scheme, and I would like to show you this scheme. So again, let's first make some quantitative analysis of the traffic. So first, there were some free communicates, the server, printer, and the server, some kind of hello. Then a lot of encrypted small packets. After this, a huge load of data from the server. Anything? Do you know what is it? Files, yeah. So, but they were encrypted. So now the real analysis of the inside communication. So the first communicate was always 263 bytes, and it was constant. So some kind of hello message. It looked like that. Whereas there is some new server crypt, so probably there is some encryption inside. A lot of null byte padding, that's not interesting. Then this communicate was the most interesting. It contained some null byte beginning, 96 bytes. Then I will call it variable x bytes, I will explain later, and null byte padding. So we were able to configure this solution, and in the admin panel it was possible to change the encryption. And you can choose between RSA 512 bits, RSA 1K, and RSA 2K. So this is an example of RSA 512 bits. And as you can see, this is 64 bytes, so that makes 500. So what is it? Yeah, the public key of, and actually, in this case, the printer sends its public key. So yeah, we thought that it was a certificate, just like in SSL. Then we thought that it would be a public key, but actually that's only 512 bits. So it actually turned out that it is a modulus number of the public key. And this is the only information about the key. So the server responded with always different 64 bytes. So what should it be? Good. Yeah, the session key for the encryption, for the symmetric encryption inside. Okay, many identical blocks in this huge load of data. What is it? I've got a picture. Okay, maybe you recognize this Linux Penguin. This is a bitmap of Linux Penguin. So what happens if you encrypt bitmap with ECB mode of encryption, electronic codebook? That's it. And that's the same what happens with the print files, because the printed files are the PostScript job files, which are basically text files. So it's extractable. Maybe it's not very easy, but it's possible to decrypt just the files on sniffing the traffic. Okay, so we had to make some assumptions for the proof of concept script. So if it was an SSL, it should be a hello, then a hello certificate, a session key, PostScript, ECB mode encrypted files, yeah, and that's it. So after, it took us quite a lot of time to disassemble this protocol to set the proper parameters for the encryption. It turned out that there is a hard-coded RSA certificate in the printer embedded software, private key, private certificate. The server contains no trustor. In this case, the client is the printer, so the server should have a trustor of acceptable certificates, but there was no. EAES 128 ECB mode of encryption used for traffic inside. So this is really not a good idea for print jobs. And we found the same protocol in admin interface, which actually the interfaces, the user and the printer and the admin interface were not separated. So we could do a man-in-the-middle attack also on the admin interface. The consequences of this attack, again, the same. All key risks are broken. But the most funny part, actually tiring, very tiring for us, was contacting with the vendor. He responded that, sorry, Many of the devices do not have the CPU power that allows a fast login response and at the same time establish a high security level. So this is the problem that the pull printing vendors face. They face the problem to choose between high security level and the fast login response, and they choose the fast login response. And they stated that changing ECB to CBC mode of encryption will be more CPU intensive and may cause slower performance, which the customers are very reluctant to see implemented. And we tried to convince them that the printers' processors are single-threaded. And on a single-threaded processor, you actually do not see the real difference between ECB and CBC mode of encryption in case of speed. Because ECB mode is faster, yeah, because it can be paralleled. And with no parallel computing, CBC is as fast as ECB, maybe like 5% slower. They tried to convince us that they are secure because the system has been deployed at many high security customers and has passed internal audits. So yeah, they passed because their penetration testing company was actually not very good. Okay, that's for the pull printing. Now, Slavik and Forex trading software.
Another example is an online application for instant financial operations. It turned out that these operations are so quick that they had to design a binary protocol because HTTP was not fast enough. So they encrypted it in SSL tunnel, a single TCP connection. The SSL was properly configured, so we looked into the packets after decrypting, but they didn't look very much readable. So we looked further and further. Well, here we can see some kind of information. I guess that's maybe stock quotations. But we looked further to the packets, and there's some clear text coming, until finally we saw something like that, which was particularly interesting. Let's have a look at it in ASCII mode. What could it be? Excuse me?
Is that a SOAP remote procedure you called?
Yes, exactly. It's encoded in this binary protocol, the SOAP. So here we have, for example, probably the path. Here we have probably the method. And here we have an answer from the server. So, of course, we tried to interrupt it somehow. It took a while to decompose the binary protocol and to wrap properly these values. But we were able to do something like that, for example. Apparently, the Axis admin wasn't properly configured on this server, so we tried other brute forcing other methods, and we found register user method. So after invoking this method, server responded incorrect login. So any ideas? Well, we thought that we don't have proper authentication. We need, for example, login and password. But it turned out that we didn't provide the parameter to the method, which was the login of the user to create. So after providing this parameter, the server responded incorrect password. So of course, we added another parameter, which was the password. The server responded incorrect first name, and then a group with name now doesn't exist. So what would you try? A group with admin. So it didn't work. Any other ideas? Administrator didn't work. User, no, it didn't work. Sorry. Excuse me? Root. Yes, exactly. We have sent them this message with the root group, and the server responded like that. of course, we tried to authenticate to that user, and it turned out that we can manage all the other accounts of the whole system. It was, in fact, a system which hundreds of thousands of users, which dealt with billions of dollars, and we could, in this single packet, we could create administrative user without even having, without even being a client of the system. So that's what I like in this job. After dealing with this subject almost 10 years, I still find this job very absorbing. So, and that's just because of the emotions it gives during such hacking. So the vendor couldn't understand how we did it. They were sure that someone has had misconfigured this firewall, so we could directly invoke these SOAP methods. They couldn't believe that we could decode the binary protocol. So, of course, there were many other problems, not just this application there, but there were no separations of administrative and internal web service calls, and two excessive error messages returned by the server. So without that, we couldn't hack it, black box at least.
Okay, so now some few cheat sheets. I think we are quite out of time. When should we end? Maybe. Okay, so if you deploy a proprietary network protocol, if you're an owner of such solution, remember to get it pen tested by a good company to verify the vendor claims. And you have to ask, like, for the secure development lifecycle, how do they handle vulnerabilities? How did they handle any vulnerabilities that existed before, and so on? Look for the CVE lists and so on, the previous bugs. And for the developers, remember that protocol is not secure by its secrecy. It doesn't work, like security by obscurity, mostly. Remember to use a proper encryption, and try to avoid writing your own cryptography. It doesn't work and probably will mess it up. Use known standards. Maybe SSL contains Heartbleed, but still it gets fixed in few hours, not just like your software. So remember about input validation, the access control inside the protocol, because these are this is the most popular vulnerability in proprietary network protocols we test, the access control inside the protocol. Use many layers of security as much as possible. Network layer security, VLANs, SSL 802.1x, and so on and so on. The least privilege principle is like the most important. And beware the backwards compatibility, like in these remote desktop protocols. Okay, Sławek, turn.
So about the hacking of these protocols, there's no simple answer how to do that. Because there are many ways to do it, and the proper answer would be that depends. Because during the penetration testing, you usually have very limited time, and you just have to choose the right path, which is the shortest path to your aim. Of course, for the beginning, we could try to understand this protocol to find its, I don't know, its internal structure, its syntax, and so on. So we could try to get some documentation. It sometimes works. You can search for this documentation on for example, developers API or something like that. We found internal protocol specification just by Google hacking. Of course, you can try to decompile the client or instrumentate the client. There are tools for that, but they have some shortcuts too. sometimes decompiling of the client is very easy. For example, not obfuscated Android application, we were able to get to this MD5 I was talking about in this Android source. But sometimes it's very hard and time-consuming, so it may not be the shortest path. So you could try to analyze this network. There are tools for that. They look very promising and great, but we didn't manage to use them in a limited time. I mean, they are great, for example, for academic research and scientific analysis of the protocol, but they didn't help us a lot. We just tried to spot some scheme of the packets, of course with a little help of other tools, and used our favorite scripting languages. So we created a small cheat sheet which we will, I hope, in a few days upload to the OWASP website about testing proprietary protocols, and it will be available on the OWASP website. So thank you for your attention, and any questions? Yes, well, we didn't have to because the SSL was properly configured. So we did upload our own certificate to the client so that we could do man in the middle and attack the internals of the protocol on the server side. Watch how this internal protocol looks and so on.
Thanks a lot. Do you have any? Have you had any experience attacking network protocols designed using Google protocol buffers?
Yeah, well,
And if you found any problems, is that due to protocol buffers or just because they used it software?
well, I've been doing some kind of small research in that topic, but with no obvious vulnerabilities.
Well. Obvious vulnerabilities. So a lot of the talk, you didn't really attack any of the protocol parsing. You didn't, from the description, you didn't try and do any fuzzing and try and do anything around the way.
Yeah, well, fuzzing. Well, did some fuzzing, like tampering the parameters is actually the fuzzing, I would say. But yeah, well, we didn't pass the Google protobuffer. Okay, any other questions? No. Okay, thank you.